His current research interests include wireless sensor networks, Internet of Things, natural language processing, and brain-computer interaction. Presently, Dr. Gupta is working on wireless sensor network based project funded by Department of Science and Technology, Uttar Pradesh. Dr. Gupta is the reviewer of many international journals, that is computer networks, wireless personal communication, information science, and IEEE transactions and extra. Dr. Gupta is also part of project funded by Royal Academy of Science London entitled with leadingindia.ai. Under this project, Dr. Gupta has organized 50 workshops on deep learning and Internet of Things. He has more than 60 research articles, authored 2 books and 2 chapters, which adds to his credit. We are really honored to have you here. There is a small change in the session participants. That is, see, session 13 is deep learning techniques and its variants, where Boltzmann machine deep reinforcement learning will be session 13. Session 14 is autoencoders and detailed discussion on the gradient descent. So there will be a small change. The morning session will be on the autoencoders and gradient descent. Then followed by that is post-break session will be deep learning techniques and its variants, where we will be focusing on the Boltzmann machine and deep reinforcement learning. This is a small change since the the resource person, the speaker is the same person. He will shift these two according to the flow that is required. Now, I hand over this session to you, sir. We are really honored to have you here, sir. Kindly take over the session, sir.
Okay. May I audible?
Yes, sir. You are audible,
Yeah.
sir.
Okay. So thank you, Professor Anupriya, for the nice introduction. And I think we should start the session. So just I'm sharing my PPT, and anyone, just any participant or organizer may confirm that the PPT is visible or not.
Sure, sir.
Yeah, I think.
It's visible, sir.
Yeah. Okay. So thank you. Okay. So good morning, everyone, and just we start the session. And first, I'll go with the autoencoder and decoder, and then we will discuss about the gradient descent methods in detail and why we are using that one. And then we go with the restricted Boltzmann machine, and after then just we go with the reinforcement learning. Okay, so before starting the session, hopefully all of you have basic concepts about the deep learning as well as neural network, and all of you know about the hyperparameters which will be tuned during the training or post training. Okay, so just I'll start the session on autoencoder. Okay, so this is the outline of my talk. So first we will go with the autoencoder, then architecture, then loss functions. Okay, so loss functions are equally important because how you have how you are going to tune the autoencoder. So that's why we will discuss about the loss function also. Then different kind of autoencoders, then application, and then conclusion. Okay, so during this session, I have designed a couple of labs. So all we go through that lab also. So hopefully all of you have a system. Okay, and obviously, if all of you are attending this session, so definitely all of you have good internet connections. So we will go with the lab in Google Colab. Okay, so labs are cloud-based, so no need to install or uh, uploading or downloading of any kind of data. So here, just you can see in the image. Okay, so in the image, just you see two things are there. One is the okay. Okay, so two part are given here, all of you can see. So one is the, here just you see input is there, so this is nothing, it's a image of digit 4, and this is the image belongs to MNIST dataset. So all of you just remember it, because many times during the presentation I'll discuss about this dataset. So MNIST dataset, I have taken one image of 4 from MNIST dataset, and simply this image is passed to a encoder. Okay, so as we are talking about the neural network or deep learning, so definitely this is nothing, it's a kind of neural network. Okay, so this neural network convert this image in the form of code, or you can say that in the form of embedding. Okay, so I'll take two examples on encoder decoder, one with respect to uh, CNN, you can say that, where we are working with the images, and one with respect to RNN, so here we will use LSTM network as the encoder as well as decoder. So here just you can see encoder. So always remember, in autoencoders two parts are there. One is the encoder and another one is the decoder. Okay, so here just you can see one image just we have passed in the encoder, and that encoder convert that image in some codes, and codes are passed to the decoder, and decoder generates a similar kind of image. So here just you can see 4 is given as an input, and 4 is also a kind of output. But yeah, of course, some information loss is there. Okay, yes, because we are converting high dimension data to lower dimension data, so definitely we will lose some of the information. And after losing the information, when again we will try to form the image, so some different kind of uh, image may be there. So maybe a possibility that you will get the exact image, maybe the possibility that some different kind of image you will receive. So just here you can see that two things are there. So encoder and decoder, and how we can define the autoencoder. So autoencoder is nothing, it's a type of neural network, and this network is trying to mimic its input closely as possible to its output. So in autoencoder, what is the overall philosophy? Means how we can judge that autoencoder is good or bad. So to check the performance of autoencoder and decoders, just you map the input image or input with the output. If exact match is there, then performance of your autoencoder is excellent. If not, then accordingly you can categorize. Okay, so already second point, just you can see here it is written that so input is transformed, okay, to its code or embedding. Okay, so reduced representation. So maybe in case of here, let's say this is 28 by 28 input size is there, and here you have generated code in 4 by 4 or 5 by 5 or something else. Okay, so actually what you are doing at here, so with the help of encoder you are mapping a larger input size into the lower dimension size. And in decoder part, what actually you are trying to do, so you are trying to convert a lower dimension data into higher dimension data. So in many places or in many books, this encoding part or code part is also known as the latent space representation. So always remember, generally what we are actually doing in autoencoder and decoder. So what kind of layers we are using in the encoder, same kind of network we are using in the decoder also, but in the reverse order. Always remember, in the reverse order. So definition. So Autoencoder describes a nonlinear relationship of an input to an output through an intermediate representation called code or embedding. So hopefully, I think all of you have a basic idea about the autoencoder. Okay, so first we are converting. So here just I am writing. So this is your input. Convert in the latent space. Okay, and then output. Okay, so this is the overall philosophy used in the autoencoder. Okay, so some important points are there. So number one, autoencoders compresses the data, okay, that is similar to what it had been trained on. So very simple, because what we are doing, so high dimension data is coded into the lower dimension data. So definitely what we are doing, so we are trying to compress the data. So during compression, we are trying to discard such kind of information which is important. Okay, so obviously if 28 by 28 matrix is there, image is nothing, image is a matrix. Okay, so let's say this is the image of kind of 3. Okay, and when we go with the or pass this image in the autoencoder, so maybe it is converted in 3 by 3. Okay, so definitely, because here total number of pixels are 784 and here 9. So what we are trying to do, we are transforming 784 pixels in 3, sorry, 9 pixel. So just I'm giving one more example. So let's say this is your neural network having 78 artificial neural network where 784 input nodes are there, and in next stage what we are trying to do, so 1 2 3 4 5 6 7 8 and 9, and again just you see. Okay, so here just you can see, in a way we are trying to, okay, so here just you can see. So if we take only this part, then what it means, we are trying to convert 784 pixels into 9 pixel, and in this portion what actually we are trying to do, we are converting 9 pixel into 784 pixels. So here just you can see, in a specific way we can say that with the help of auto encoder, we are trying to compress the data also. So let's say for the training of auto encoder and decoder, you will pass 50,000 images. Okay, so based on your data, a specific compression has been taken place. So this is one important point. So just I'm removing all the things so that we can go with another point. Okay, so next point is there, that is unsupervised training. So in case of auto encoder, there is a no need of labeled data. So unsupervised means data is not labeled. So you have the input data, just you pass that data in autoencoder model, and you will generate some kind of output. So, so whatever the input data is there, that actually pass in the network, and the same data can also be utilized for uh, checking the performance of your autoencoder network. So this is another point. Okay, so one is data specific compression. Another point is there, that is the unsupervised nature, no need of any kind of labeled data. And third one is there, that is the lossy in nature. Okay, so always remember autoencoders are lossy in nature. The major reason behind is that because in encoder part you are trying to reduce the dimension of your input data, and from low dimension in decoder part, using the low dimension data, you are trying to convert that data in high dimension. Okay, so actually with the help of encoder and decoder, if you want to get 100% accuracy, then the size of your data should be so large. Okay, so and as such there is no definition of what is the meaning of large. Okay, so as much as possible, whatever data you have, you can utilize that data for training the autoencoder. So always remember 3 points in with respect to autoencoder. One is the data specific compression, or you can simply say that compression. Another nature is that is unsupervised, and third one is the lossy in nature. Okay, so if we talk about the general computer science, then different kind of data compressions are there. One is lossy and then non-lossy. So we are not going with that one. Okay, so here just you can see this is the architecture of auto encoders. So here input is there, and this is your neural network actually. This is your neural network. And this is also the neural network. Okay, so one part is encoder. So here just you pass the input, and after then hidden layers are there, h1 h2. Okay, so maybe less number of hidden units are there as compared to input. Okay, and then in hidden layer 2 again less number of hidden units are there as compared to h1, and same architecture is followed in the decoder part, just you can see. Okay, so in which manner we have coded the input data, in same fashion the coded data is converted in the output. So you have to be careful about the architecture. You cannot mismatch the hidden units in encoder and decoder part. So this is a complete architecture of the autoencoders. So what you can do, you can use one hidden unit, you can use two hidden units, you can use multiple hidden units. So while you are going with the multiple hidden units, then that kind of variation is known as deep autoencoder. Okay, so just we are moving ahead. So here just I'm going with one uh, introduction about the ANN also. So how the ANN is working, because I assumed all of you have attended some of the sessions in this workshop, or previously you have attended some sessions where you have the idea about the artificial neural network. So in case of artificial neural network, okay, so always remember one input layer is there, some hidden units are there, or hidden layer with hidden units, and one output layer is there. Okay, so this ANN network is related to classification. So all of you are able to see here. Okay, so all of you are able to see the hidden units in output layer. So here M and N is different. Okay, so maybe the value of M is 784 and value of N is 10. Okay, why I had taken this 784 and 10? So because in MNIST dataset, MNIST, sorry, MNIST, in MNIST dataset, all the samples are of size 28 by 28. If you multiply it, then 784 means in MNIST dataset, single image is having size 28 by 28. Okay, so if we convert in a column vector form, then 784 values are converted in 784. And why here the value of n is 10? So because MNIST is the data of handwritten digits. Okay, so how many digits are there? 10 digits are there, 0 to 9. So obviously whatever sample you will pass, that sample should belong to any of the class. Okay, so let's say this is your trained artificial neural network, and if you pass the test sample, obviously that test sample belongs to any of the class. So that's why here it is in output layer, nodes are given. And what is the concept actually, how this uh, artificial neural network will get trained? So the concept behind is that obviously one input layer is there, and in input layer you will pass the feature. In this case, with respect to this MNIST classification problem, 784 features are there. Each pixel is acting as a feature. Okay, so in input layer, just you pass the feature. All the nodes of input layer is connected with all the hidden units in the next layer, and then all the nodes of hidden unit is connected with the all other hidden units in the hidden layer 2, and then connected with the output layer. Now the question is that at which state we know that our model is the best. So to check for evaluating the performance of any deep learning or neural network model, we minimize the loss. Okay, so for computation of the loss, you can go with the categorical cross entropy loss or RMS. So different kind of loss functions are there. Log likelihood function is also there. So you can use any one of that functions. Okay, so what is the role of that function? The role of that function is to compute the loss, okay, in the model. Okay, based on the loss, some kind of adjustment is there in the network. Okay, so where we can do the adjustment. So always all of you I think know one is weight and another one is the bias. So you have to go with some kind of adjustment in weight and bias. Okay, so gradient descent in after this session we will discuss about the gradient descent also, and that can also be utilized for the adjusting the weights. So here just you can see, so what is the weight? So on each edge some kind of weights are there. Okay, so just you adjust the weight. Okay, so you pass the input data, compute the loss at here. Based on the loss, you have to provide the changes in the weight and bias. Again, you check the model after updating the weight and bias, compute the loss. So obviously some kind of change in is there in the loss, and then again you update the weight and bias, then again you change the sorry again you compute the loss. So you have to follow these instructions for certain number of epoch, let's say 100, 50, 200, whatever you want. Okay, so initially all the weights and biases are generated randomly. Okay, so random generation is there for weight and bias initially, but after each and every epoch there is a change in the weight and bias, and after certain number of epoch your model is stable. And then what is the meaning of stable? So stable means there is no change in the loss. So let's say after 50 epoch, now you are training your model, but there is no change in the loss. And if there is no change in the loss, then there is no meaning of training that model. And that model is the optimal model with respect to your problem. Okay, so other mechanisms are also there if you want to improve the performance of model, then other concept like overfitting and underfitting. So I'll discuss all such kind of things with respect to autoencoder also. Okay, so again, components. So three major components are there in the autoencoder. So one is the encoder, then code or embedding, and then decoder. Okay, so now the question is that hyperparameters in the autoencoder. Okay, so here just you can see.
Excuse me, sir. Hello.
Yes.
Sorry to interrupt, but I'm a very beginner. Sir, please explain why auto encoders are required. Why, and where exactly they are required. What is the application of it? Sorry to
Okay.
interrupt. Thank you.
So no problem, sir. Actually, I had taken that one in later part. So if you can wait, then fine. Otherwise, I had to uh,
Okay,
go
no
and.
worries, sir.
Yeah. Okay, so already I had taken the examples. I think, yeah, here just I have taken, but
Okay, no worries, sir. We can discuss afterwards.
yeah, sure. Okay, so next one is there, uh, hyperparameters in autoencoder. So what do you mean by the hyperparameters in autoencoder? So number one, anyone can ask how many layers, hidden layers should be there in encoder. Okay, this is one question. So layers is one of the point. Anyone can say that how many hidden units should be there. Okay, so this is another point. Okay, because it's a challenge. I'm working on the autoencoder, so I can go with 10 hidden units, sorry, hidden layers. Any other person is there who can go with the 20 hidden layers. Anyone can go with the thousands of hidden units. Okay, so these are the challenge. Okay, and we have to find out the optimal set of hidden units and hidden layer in autoencoder for the with respect to best performed model. So here just you can see number one is the code size. Okay, code size, this is one hyperparameter.
Sir, what's the
Okay.
difference between hidden layer and hidden units?
No. So here just you can see this is the hidden layer.
Yes, sir.
Okay. And
Okay.
how many nodes are there? 1,
1,
2,
2,
3, 4, 5, 6, 7, 8.
7, 8. Yes.
Hmm?
Yes.
Okay. So hidden unit is 8. And how many hidden layers are there? 2. This is also.
Okay.
Okay.
Yes, sir.
So you can go with one more because it is dependent on you. Okay. So you can add one more. What is the issue? Okay. So similarly, you have to provide changes at here. Okay. So just I am removing this one. Uh, okay. So one is the code size. Code size means number of nodes in the middle layer. Middle layer means in these layers. Next one is there, that is the number of layers. How many layers should be there, or how deeper your network is. Maybe 2 layer, maybe 3 layer, maybe 4 layer, whatever. So this is another hyperparameter. Okay, so number of nodes per layer, but always remember, never try to reduce the hidden units in input layer. Okay, so in input layer always you will pass the features of your data set, features, and if you reduce the feature, then what will happen? Your model will not get trained properly. So never try to reduce the nodes in input layer. So always you have to take care of that one. But what you can do, you can change the hidden units as well as hidden layer in the hidden layer and hidden units. Okay, so next one is there, loss function also is there. So which kind of loss function you are using? So you are go with the categorical cross entropy loss, or you are going with the MSE. So hopefully all of you know about both the things. Okay, and I think I'll also discuss about the binary cross entropy as well as MSE in later slide also. Okay, so another challenge is there in case of uh, what we call autoencoders. So I'll take one example. Okay, so what is the example here? Just you can see, suppose you are working with the classification problem. Okay, so you developed a neural network, artificial neural network. Okay, so just I'm making it small, and classification of the handwritten digits. Okay, so just I'm not making all the connections, so please assume all this network is connected. Okay, okay, so maybe possible that you have started training of this model, and during training during training, or you can say that if you pass a test sample which belongs to the training data, then its accuracy is 100%. Okay, and when you pass unseen sample, suddenly the accuracy of your model is 50%. So if such kind of situation is there, then you can say that model is in overfitting state. Overfitting means model has memorized the data. So here just you can see two classes are there. One data sample is represented by cross and one is circle. So here just you can see this is the situation. Here model is trying to memorize the data of one class. Just you can see. Okay, so model is trying to fit with respect to classes. If such kind of situation is there, during training the performance of model is 100%, but for unseen sample or for the test samples the performance suddenly goes down, then you quickly check that your model is in the overfitting state. Here another thing is there. Okay, so that is underfitting. Underfitting case of underfitting is means let's say performance of your model is 60%, 70%. Here I'm talking about the classification model. Okay, so 60% accuracy is there, 70% accuracy is there, and if such kind of situation is there, so definitely your model is in the underfitting state. Okay, and let's say accuracy of your model is 93, 95, or 89, something like that. So this is the best fit. Now I'm taking another example of overfitting and underfitting. Okay, so hopefully all of you belongs to academics. Okay, so I'm taking one example, real life example. So in a class, and let's say 60 students are there, and I'm taking the course of data structure. So couple of students are there, those memorizes all the content whatever I have delivered. Okay, let's say 20% students are there, and that students has memorized each and everything what I have delivered during the class, as well as whatever study material I have passed, they have memorized. Whatever link or other resources I have shared with them, that they have also memorized that thing also. And if during the mid-semester examination, if I'll uh, put the questions from that material in the question paper, then that 20% students will secure 100% marks. Okay, because whatever they have memorized, exactly that questions are available in the examination, so definitely they will get 100% marks. But during the at the end of the semester, some questions from means question paper from outside institute, and they have given some question, and that questions does not belongs to the content whatever I have provided to the students. So the performance of that students suddenly goes down. Yes. Hello. Hello.
ఆహా.
Yeah, Anupriya ma'am.
అవును మరి అమ్మో ఇంట్లో నచ్చింది తెలుసు మ్యామ్
Hello.
మీరందరు కార్లో వెళ్ళిపోతా అంటే అబ్బా అనుకున్నా నేను. తర్వాత నేను ఎక్కడ నడుచుకుంటూ వస్తా అంటే ఎంత నడిచినా అంటే కొద్దిసేపటికి ఒక స్టార్టింగ్ ఒక 5-10 minutes తర్వాత వచ్చినాం అన్నట్టు. ఇక ఎంత నచ్చినా అవుతుంది ఉండదు ఇంకా.
హలో
మేము అదే అనుకున్నాం ఇంకా అమ్మ అట్లా అదే స్కూట్ అయితే బెటర్ అని.
హలో yes Anusha. Yeah, some noise is there, so I thought means anything happened or what, I don't know. Yeah,
Dear
Anusha.
participants, please make yourself mute.
Yeah, okay, thank you Anusha. Okay, so just
మంచి బెటర్ అది తొందరగా టైం సేఫ్ అవుతుంది మంచిగా.
hello
Anusha ma'am, please
This is
make
from
yourself
Anusha
mute,
ma'am.
ma'am.
ఏ సబ్జెక్ట్ మేడం అది?
Anusha ma'am. Anusha ma'am, please make yourself mute, ma'am.
Participants, please make sure that you are not disturbing the session.
Yeah, the whole means organizer can also mute, I think so, but anyway, okay.
I'm muting, sir. I'm muting everybody. I'm muting everybody, but I'm giving them option, because it should be an interactive session.
Yes,
They should have their doubts clarified then and there, no, sir. When I was trying to accumulate, they were having difficulty. Then even the presenter have to go back to the slide and explain. So I gave them that option, so that they can interact with you then and there. See, all are responsible people and matured people. Please realize the responsibility and kindly do not unmute and do your family, like a business or talking or any official thing also. This is my kind request to all of you. Please. I'm muting all right now.
Yeah, okay, but I think for some time you can unmute, but after that just unmute. Okay.
I have muted, sir. If they want to speak, let them unmute and speak.
Yeah, sure. Okay, thank you, ma'am. Thank you. Okay, so just I forget where I was. I think I was discussing about the overfitting. Yeah, it's a very important concept because underfitting and overfitting both kind of a common situation in the deep learning model. Okay, so I'm discussing about the overfitting and how we can analyze your model is in the overfitting or underfitting state. So number one, how you can identify. So let's say during the training, the accuracy of your model is 100%, and during the test, the accuracy of your model is 50%. So it means your model is overfitting state. And to understand what is overfitting, so the best example is obviously whatever I have discussed, that in a class 60 students are there and 20% students of that class are always trying to memorize all the content delivered by the teacher, all the content delivered by the teacher, either in the form of notes, either in the form of resources, either in the form of lecture delivery, okay, anything. So all that 20% students have memorized that content. So in the next semester examination, let's say students, teacher will prepare a question paper, and in that question paper, if teacher will pass the or to put the questions from whatever content he has delivered in the throughout the semester, then definitely that 20% students will secure 100% marks. Okay, but at the end of the semester, the question paper was designed by the university, and the same set of students will only secure 40% or 50% like marks. So this is a situation of overfitting. So these 20% students memorize the data rather than analyzing the data. Okay, so these 20% students had tried to memorize the data. So that's why if the questions from the set what they have memorized, performance is 100%, and questions from outside that memorized set is there, then the performance is 40% to 40 to 50%. It's a assumption. Okay, so if such kind of things is also there with respect to your model, then your model is in the overfitting state. Okay, so this is the case of overfitting. And I'll discuss what are the possible reasons for the overfitting. Don't worry. So before that, just I'll discuss about the underfitting. Okay, so in case of underfitting, you can take one example. In a class, around 10% or 5% students are there. Those who never attended the class, who never gone through the material provided by the teacher, who never studied from other resources. Okay, so actually that 10% or 5% students are not engaged in the training. So what will happen? So either midterm or what we call said that mid semester examination or end semester examination, in both cases the performance of that 5% students is poor. Maybe 30% here they have secured and 35% here. So we can say that uh, the that students have not gone through the proper training, or you can say that all that students are in the underfitting state. So two popular terms are there in deep learning. One is overfitting and underfitting. So actually what happened in real life, whatever model we are developing or whatever applications we are developing, so we always try to train that model on a defined data set, and suddenly if you deploy that model for the some real kind of application, the performance of that model suddenly goes down. Okay, so I'll take one example. Okay, just wait. Just wait. Okay, so let's say just I developed a model that is object detection. Okay, and this model is trained on predefined data set. Okay, whatever data is available publicly, predefined, where each and every object is clearly placed, clearly visible. But if you deploy that model for the real life application, okay, so maybe object overlapping may be there. Okay, maybe some light issue is there on the objects. Maybe only 30% or 40% objects is visible. So different kind of scenario is there. So because we had trained the model with respect to predefined model, okay, predefined data set, okay. So in that case, when you go through the real life deployment, because you didn't consider the cases like overlapping of the object, visibility of the object, orientation of the object. So in that case, that model will fail. So the reason behind for the failure of the model is that training is not proper. Training is not proper because we didn't consider such kind of situation during training of our model. So that is the case of underfitting. In case of overfitting, okay, so overfitting case, model has memorized the data set. So if sample from that data set, then fine, then accuracy is good. If unseen samples are there, then it fail. and this is appropriate fitting. So possible reason for the overfitting is there. Okay, just I'll take one example. So maybe if you have more number of layers, okay, more hidden units. These are the tentative, not exactly. Okay, so more hidden units. Okay, so if you add more number of layers in the neural network and more number of hidden units are there, so what will happen? A couple of nodes will memorize some set of data set or some specific features of the from the samples. Okay, so the memorization chances in case of more number of layers and more number of hidden units is high. Okay, the possible reason for underfitting is there. So your architecture is very small. Let's say 784 hidden units are there in the input layer, and just what you are trying to do, only in the next layer you had taken 4. Okay, and then again you are just you see 2 hidden units, and then at the output layer 10 hidden units. Okay, so let's say if such kind of situation is there or such kind of network is there, so what do you expect? The performance of this model will be good? No. Why? Just here you see in this architecture, you are trying to convert 784 information into only 4 nodes. Okay, so just you see, a huge loss is there at here in this between these 2 layers. Huge loss is there. Huge loss in the information. If huge loss in the information is there, definitely what your model will learn. Okay, so you have to go with the relevant number of hidden units in the hidden layer. So now anyone can ask, what is the thumb rule? How we can select the hidden units in the hidden layer with respect to the input? So as such, there is no thumb rule. But what you can do, you can start with 16, 32, 64, and you go with some kind of hit and trial method. Or what you can do, you can go with 128 hidden units in each layer. Okay, and after building the model, you can compress that model, or you can uh, remove the redundant node. Okay, so this is the possibility. So if less number of hidden units and less number of layers are there, then there is a higher chances that your model will be in underfitting state. If you go with more hidden units, more hidden layers, then higher chances are there your model is in overfitting state. Okay, and yes, so how we can uh, avoid the underfitting state? So for avoiding the underfitting state, what you can do, you can add more training data and change the architecture of your model by adding hidden units and hidden layer. Overfitting, in case of overfitting, what you can do, you can pass or increase the size of the data, number one. Number two, you can use the dropout, okay, in the architecture, or you can go with the normalization technique, or you can also change the architecture of your model. So these are some possible solutions to get right from the overfitting and underfitting state. And always remember, in both the cases, means both the situation is dangerous, and this is the role of a deep learning or AI expert to find out a optimal model with respect to your data set. So here, what is the meaning of optimal? You have to find out architecture with the help of minimum hidden layer with minimum hidden unit. Okay, and your model should be sustainable with respect to um, if there may be some kind of variation in the text test image. Okay, so I think all of you have idea about the overfitting and underfitting and then dropout. So any question at this point of time you can ask, because these two concepts are too much important. Okay, so means in my mind, I have an assumption that all of you know about the artificial neural network, how the weight change is there, what is forward propagation, backward propagation, what is the loss, what kind of optimizers are there. So I assume you have the knowledge about all such kind of thing. If not, then I'll provide some uh, thoughts on all these things also. So yes, please, if any question, then please you can ask, or you can type in the chat window. So one question from there, that is Raja M, is appropriate fitting good? So appropriate fitting is good, yes. It is also known as the best fit. Okay. So your model neither in the overfitting state nor in the underfitting state. Okay, so in case of one more question is there, that is by Sharda. Okay, so what is the difference between autoencoders and pooling? If I'm not wrong, you are talking about the max pooling, average pooling, then mean pooling kind of. No, yes, okay. So in case of max pooling, okay, let me explain. Okay. Okay, so actually what this concept is there, so this concept is utilized in the convolution neural network. Okay, and in convolution neural network, after the convolution operation, okay, yes, of course. So let's say one image of size is there, 28 by 28. Okay, and when you apply a filter of size 3 by 3 on this image, so one formula is there to change the n minus f plus 1. Okay, f is the size of the filter, okay, and n is the number of size of the image. So in this case you will get a size of 26 by 26. Okay, so after applying the CNN convolution filter on 28 by 28 image, and the size of the filter is having 3 by 3, you will get an output of 26 by 26. Okay, so let's say assume 26 by 26 size is there, and it is an image, so definitely the all the pixels are not carrying the equal weighted information. Okay, because in case of image there is no a great change between the nearby pixel values. So if we discard a couple of pixels, even though we are able to analyze the or identify the image or object. So during pooling, what we are doing, we are converting this matrix into lower size, or you can say that we are going with the downsampling. Okay, so during max pooling, so let's say size of the pool is 2 by 2, then we make a block of 2 by 2 throughout the image. Okay, so we can make a block, and whatever the maximum values there, just we can pick. Okay, so if we pick the maximum value, so definitely this 26 by 26 size matrix is converted in 13 by 13 or something else. Okay, so what, and with the help of pooling, what actually we are trying to do, we are trying to get the important values of that image for the next operation. So in this manner we will reduce the computational cost, Okay, we will trying to reduce the computational cost. So generally, what is our philosophy that maximum value is containing more information. Okay, so if we collect all the maximum values, then our model will get trained in a positive way. So this is our a general thought. For more detail, then we have to start from the convolution filter, and then we have to go all the discussion on that one. Then mathematically we have to check this max pooling is best, or min pooling is best, or average pooling is best. Okay, so is auto, I think Sharda, I am able to answer your query, hopefully. But in case of, okay, is autoencoder is a pre-trained model? I didn't get this point, because autoencoder is a kind of architecture. Okay, and you train that model on some data set, and if you would like to utilize the weights of that model with respect to other model, you can go with that one. No, Sridevi, the question is that whatever architecture you are using in the encoder, same architecture you have to use in the decoder also. Same kind of architecture. Okay, so in what manner you have decoded the data, in same manner you can, in what manner you have encoded the data, in same manner you have to convert the encoded data in the decoding part, on which data set autoencoder is trained. So Dr. Harijit, actually it's a unsupervised mechanism. Okay, so it's an unsupervised mechanism. So any data set you can take, if you are working on the images, you can go with the MNIST, fashion MNIST, then cipher 10, cipher 100, any data set. These are the popular one, freely available. So that's why I named all these data set. And if you have your own data set, you can also use autoencoder for that data set also. Okay, so as such, there is no. So yes, Sridevi is sharing a very good thought, why we should not use the VGG16 architecture in autoencoder and decoder. Okay, so maybe you have to change the max pooling layer, pooling layers in the VG16 architecture. Maybe you have to remove that one. Okay, so any other question, then just you can ask quickly.
Sir, I don't think there are any further questions.
Yeah, that's fine. Okay.
So I think we can start with the.
Yeah. Okay, so these are the popular challenges in autoencoders. Okay, so in case of overfitting, I discuss one more concept, how you can remove the overfitting. So that is the dropout. Okay, so this is also one of the good mechanism. So in case of dropout, nothing. Very simple example I am taking. Okay, so this is the 784 nodes, then 10, let's assume 10 hidden units are there, and then 10 we make it 100. Okay, so this is the architecture. In case of dropout, let's say you have applied the dropout at this hidden unit. Generally we apply the dropout at hidden unit, because if we apply the dropout at input layer, then definitely we are losing some of the information. So already if we lose some information, then the training of your model is not good. Obviously we cannot apply at the output layer. So in case of dropout, let's say at this layer I have decided that dropout equal to 50%. So always remember, if dropout equal to 50%, it means in each iteration, 50% nodes in this layer will not participate in the training. Again, I'm repeating. Okay, so let's say dropout equal to 50%. It is not mandatory. You have to go with 50% dropout. You can take it 5%, you can take it 1%, you can take it 50%, you can take it 90% also. I had tried with 90% also. But in that case, number of hidden units are too much. Okay, so the value of dropout is not fixed. So now the question is that then what is it, the meaning of this one? So it means 50% hidden units are randomly selected, and that 50% hidden units will not take part in the training. Obviously, if 50% hidden units will not take the part, then your model lose some of the information in each epoch. If your model will lose some of the information in each epoch, then your model will never reach to the overfitting state. This is the overall concept behind the dropout. What means if X amount of nodes will not take the part in the training, then your model will lose some of the information. If model will lose some of the information, then model will never reach to the overfitting state. So this is one concept. Okay, I think I'll take one hands-on. Okay, so that all of you have idea about all the things whatever we had discussed about dropout and all. Okay, so then we cover a couple of slides and then we go with hands-on on autoencoder also. So just I'm checking the lab and explain each and everything. So that, yeah, of course, this one. So just I have pasted. Again, I think Rajshri, I think you are talking about the overfitting and underfitting because you have posted one question in the chat window. So hopefully you are talking about the overfitting and underfitting. So in case of overfitting, you can use normalization, you can use the dropout, you can change the architecture of your model, you can increase the data set. Okay, so for overfitting, increase the data set, regularization, dropout, and then change the architecture. In case of underfitting, change the architecture, increase the training data. Okay, if you go with the dropout, then reduce that dropout. Okay, so these are the possible solution. Okay, so all of you just open the lab, and this lab is related to ANN. Okay, so I think all of you have opened it. Just anyone confirm me. And hopefully all of you have some basic idea about the Python and its different libraries like TensorFlow, then Keras. So I am assuming all of you have the basic idea about the Python and all these things. Access denied is coming. Okay,
access denied.
Yeah, just wait. Anyone just send me the request. So what I will do, I will go to just anyone. I'm not sharing my screen. Oh, so many. Okay, just wait. I'll change the setting of that one. Yeah, just I forget to change that one. No problem. Uh, I think now all of you are able to open it. Again, I have posted the updated link. So anyone just confirm?
Actually, we're trying, sir.
Okay, so I think it's opening. So no problem.
It's
Sorry.
done. Done.
Sorry, just I have forget to change the setting.
No issue, but done. Now it's done.
Yeah, okay, thank you. Okay, so all of you have just opened it, and hopefully all of you have experience to work with the Google Colab. So simply you have to execute one. So one by one, I'll go with the one explanation of one by one each cell, and then we go with that one. Go with the lab. Okay, so just all of you execute it, or all of you run all the cell in a single click. So hopefully there is no error in the file, because already I had tested it yesterday night itself. Yes, so there is no error right now. Okay, so save the model. I had to check why this error is there. Okay, one error is there, so that is not too much important right now. Without that, we can work. Okay, so just I'm providing an explanation about individual cell. So here, just you can see some important points are there. So this in this Jupyter, in this Python notebook, I'm going to use Keras library. Okay, so Keras is a library which is built on the top of the TensorFlow and utilized for the development of deep learning models. Okay, so this is the popular one, and Keras is the easiest way. Means with the help of Keras library, you can easily write a deep learning model. That model may be for the classification, or model for the object detection, or model for the in case of natural language translation, etc. Okay, so here just you can see I have imported NumPy. So NumPy is nothing. It's a numerical Python for performing matrix operation. In a short, you can just remember. So we are going to use this MNIST dataset. So during my session, I had talked about MNIST dataset many times. So I think all of you are also familiar with that one. And then sequential and model underscore from JSON. So we are going to import sequential and model underscore from JSON. Okay, so if you want to find out the detail, just you put a cursor and you will get other details about that function or library. Okay, so just sequential, yeah. So here just you can see layers. So here see dense layer is there. Okay, and if you're working with the CNN, then convolution layer, then max pooling and dropout, different kind of layers are also there. Okay, so then optimizers we are going to use. So RMS prop. So during session I will also cover a different kind of optimizers. So basically optimizers are helping to fasten our convergence process. Okay, so this in deep learning, what actually we are trying to do? In deep learning, we are trying to solve an optimization problem. And what is that optimization problem? So our objective is to minimize the loss by changing the W and B. I think 1 minute, just I'll take one slide. Okay, so our objective is, so in case of deep learning, so this is our minimize minimize loss. Okay, and what is for the computation of loss? You can use the categorical cross entropy formula, or you can go with the RMS prop. Two I'm mentioning right here. So we have to minimize the loss. How we can minimize it? So by changing the W comma B. What is W? So W is the weight, okay, and B is the bias. So maybe some, okay, so W comma B. So you have to update the W and B to minimize the loss. So formula is generally we use W dash equal to W minus alpha dW. Okay, and how you can update the bias? So B dash equal to B minus alpha dV. So this W dash and V dash is the new weight and bias, which is always dependent on W, previous weight, and previous bias. And this W, dW and dV is the gradient, and alpha is the learning rate. Okay, don't confuse with this alpha. Alpha is the learning rate. So generally the range of this alpha is 10 power minus 4 to 10 power minus 2. This is the value. So alpha is okay. In this session I'll discuss about the alpha also. In one slide I think I put alpha, otherwise we will go in the wrong direction. Okay, so here just you can see, so basically we are going to use this sequential model, and layers we are importing, that is dense. We are going to use the optimizer RMS prop. So this optimizer is also available in the Keras library, so only you have to call that one. Next one is there. This is the important cell. Okay, so all of you just see it, and so first point is there, that is the batch size. So batch size is nothing basically. Okay, I'll take one example. Okay, so just I'll explain. Okay, yes, I'll take the example of batch size. Okay, so let's say you have the, I'll take example of 60,000 samples. Okay, so what you can do, let's say this is your neural network. Okay, and in that neural network, either one sample you pass, okay, obviously, and then compute the loss. Here you have computed the loss. Now what you can do, you change the weight and bias. You change the weight and bias on the basis of this inputted sample. Okay, so one sample. For second sample, you have to change the weight and bias. Then for the third sample, again you will change. Okay, so just you see how many times you have to repeat the operation. 60,000 times. After 60,000 samples has been passed, then one epoch will be over. Maybe the possibility that for sample number 1, W is moving up. For sample number 2, W is moving down. For sample 3, W is moving down. For sample 4, W is moving down. 5th, 6th, 7, 8, 9, 10. Now W moving up. Means up and down means positive, negative. In one iteration, you have added some weight. In some iteration, you have reduced the weight, maybe the possibility. So you see, if up, down, you are going, then when you will converge. So one concept is there, that is the batch. What you can do in uh, just you take the decision for updating the weight and bias based on the batch. So suppose 120 updation in the weight and bias is made after analyzing the 128 samples. So for 128 samples, some of the, with respect to some samples, positive, negative. So we will take the average or norm. Okay. So we will take the average or norm, and based on that norm, we can change the weight and bias. Okay. So rather than changing weight and bias with respect to a single sample, now we will take the decision after analyzing 128 samples. So this batch size is also one of the hyperparameter. You can take it 1, you can take it 4, you can take it 5, you can take it 1000, you can take it 10 power 6. Okay, so based on the size available in your primary memory, you can change the size. Okay, let's say another example I can take. So one data set is there, Google landmark detection. 40 lakh images are there. Okay, in the training, or I think 15 lakh images for the testing. So suppose you want to send all these 40 lakh images in the model in a single shot. So I don't think so any system is there which having the capability to load 40 lakh images or store 40 lakh images in the memory, and if the size of one image is 1 MB. Okay, so just you see 40 lakh, okay, 4 million multiplied by 1 MB. So just you see what should be the size of the primary memory. Okay, so both the things are there. If you, because due to the memory restriction, it may be possible that we are not able to pass all the training samples in a single slot. If we go with a single image, then it will take too much time, and model requires huge amount of time to reach to the optimal state. Both the things are not good actually. So what is the solution? We can pass the data in a neural network, in artificial neural network or CNN, in form of batches. Okay, so here in this example, we have taken the batch size 128, and number of classes is 10 actually. So number of classes is 10 means, because we are working on the MNIST data set, then number of classes is 10. Epoch equal to 2. So how many iteration you have to perform on the training data? So that is 2 epoch. So 1 epoch means compute the loss, update the weight and bias. In second epoch, compute the loss, update the weight and bias. Now training is
Sorry for the
done.
interruption, sir. One doubt in between.
Yes.
Sir, batch size you told we will be giving 128. Many coding I have seen, many models I have seen that it is different, 64, 32. So what is the difference? How it will
No,
be?
I told you, you can go with batch size 1, you can go with 5, you can go with 10, you can go with 10 power 6. It's up to you. So as such, there is no thumb rule that this is the value of batch size. Okay.
Okay, sir.
So,
Okay, sir.
so you have to apply your intelligence, and you can find out what batch size is best for this network. Okay, so yeah, of course you can try with 32. You try with 128. With respect to 32, means you are achieving good accuracy, and when you pass the data in form of 128, then you are achieving the less accuracy. So what it means, 32 byte size is better as compared to 38. So now again you have to make one more trial with 16 and with 64. If you are getting a good accuracy with 16 as compared to 32, then again you try to go with the 8 or 4. So in this manner you have to means find out the optimal value of batch size. Rashri, yes, you can in Google Colab, if you are working, so you can suppose you build a model for the classification. So you have to upload your custom data in Google Drive, and you have to provide the path of that directory while you are loading your data in Google Colab. Okay, so generally I do not prefer such kind of activity because different users are there, then different kind of errors are there, and in that case we lose lots of time. So that's why during our experiment we use the data of Keras. But lastly, lots of codes are available in GitHub, okay, from where you can see how you can load your data, custom data in Google Colab. Okay, so I'm just going to this splitting. So here what we are doing, we are trying to split the data in two parts, train and test. Okay, so training data set is required to train the model, test for the testing purpose. So here just you see 60,000 samples are there for training and 10,000 samples are there for the testing. Okay, and 784 because the size of the image in MNIST data set is 28 by 28. So we have disabled that data. So now we are working on the column vector. In ANN, we are working with the column vector. In CNN, we are working with the matrix. Okay, so that's why matrix operations are there in CNN. So float 32, I don't think so. Here, what we are trying to do, we are normalizing the data. Okay, so what we called, yes, in image, black and white images are there, so pixels are there, and the value of each pixel is ranging from 0 to 2 to 55. Okay, so now at this point of time I have just divided each pixel by 255, so data in the range of 0 to 1. Okay, so okay, so any question? So participants, please write your question in the chat window if you have. Okay, so that I can answer parallelly. Okay, so just I have yeah, you can ask the means you can what we call you can write in the chat window also. So I'm able to see both the screen and chat as well as live also. Okay, so now the next cell is there. So here in the next cell we are trying to visualize the data, means what kind of data is there. My screen is visible, lab notebook. Yes, anyone can confirm.
No, sir. No, it's
Okay,
not.
okay, lab notebook is not visible now.
Yes, sir.
This is visible now.
Okay, so I'm now it is visible. So I'm actually I am having the another monitor. So I am using the extended property of display. Okay, so now screen is visible, I think.
Yes, surely.
Yeah, that's fine. Okay, thank you. Okay, so visualization of the data. So just we have done it, and this is the important shell where first layer underscore size equal to 32, then model equal to sequential model dot add I think all of you have executed this cell.
Yes.
Okay, so here one important point is there, that is the activation. So activation is nothing. Activation is basically converting your data, okay, in non-linear way, because non-linearity is also equally important if you are working with some kind of decision making problem. I'll let you know how. Okay, so here just you can see just F5. Okay, so let's say you have the data in so this is your data. Okay, and another data is like this. Okay, so if you want to make a classifier, then you can easily make this one like this. Okay, and this is a line y equal to mx plus c. I don't know what is the value of m and c. Okay, so with the help of this line you are able to classify the data, but maybe possible that your samples are like this, this kind of something. Okay, so I don't think so there is any line by which you are able to classify these data set. Okay, I don't think so. Okay, in this, either this way, no, there is no line. Okay, so because you are able to separate these data sets or these data points with the help of non-linear, with non-linear equation. Okay, so to provide the non-linearity in a neural, in the model, we have to use activation functions. And another role of activation function is also there to squeeze the data, or normalization also can be utilized. Okay, so let's say a very high value is there, then you can make that value closer to or in the range of 0 to 1. Okay, so here activation function we are using, that is sigmoid. And then so in first layer, in input layer 784 nodes are there. In first hidden layer 32 nodes are there. Again one more hidden layer is there, 32 nodes are there, 32 nodes are there. And then at the last output layer is there. So I'm going to explain, just here you can see the number of parameters. So from here you are able to exactly understand how this neural network is, or artificial neural network is working. So just we take one example in this. Okay, so just so first hidden in at input layer 784 nodes are there. Okay, and another in first hidden layer 32 hidden units are there. Then one more 32 hidden units, and then one more 32 hidden units, and then at the last 10 hidden units. So just you see what kind of fully connected. So all the nodes in the input layer is connected with other nodes in the next hidden layer. So how many connections are there at this point of time? Anyone let me know? How many connections are there? So 784 multiplied by 32. So this node is connected with 32 another nodes, and 784 such nodes are there. So this is the, so what is the value of it? Anyone? I think if I'm not wrong, so it is
25120.
yes,
25120.
okay, no, I think it is 088. Anyone confirm?
25088.
Yes, 25800. Okay, so now, so these are the weight actually, W1 to Wn. These are the weight. So 25088 weight. And I think all of you know that with respect to each hidden unit, one bias is there. So 32 hidden units are there. So 32 bias are there. So it is 25120 number of trainable parameters. So in neural network, two different kind of parameters are there. One is the trainable parameters and another one is the non-trainable parameters. So what is the meaning of trainable parameters? So meaning of the trainable parameters is that during training, the value of that parameters will change. तो हम क्या करते हैं? What we are doing? So in every epoch, we are trying to change the value of weight and bias. That's why weight and bias are the trainable parameters, and non-trainable parameters are like standard deviation, then mean. Okay, so initially we have computed the such kind of parameters, and throughout the training, all that parameters are the constant. So we can say that are the non-trainable. So similarly, if we go the one deeper more, so 32 nodes are connected with 32 plus 32. So I think after then 1056 parameters are there, then 1056 and then 330. If I'm not wrong, anyone just confirm? Anyone?
Yeah, true.
Okay. Okay, so my guess is correct. Thank you for the appreciation. Okay, so this is your network. Okay, now the question is that okay, so later on I'll explain some other thing also, and just come to the lab. Okay, so where is the lab? Yeah. Okay, so here just you can see trainable and non-trainable parameters. I think all of you have understood it. Okay, so now I think all of you are able to see such kind of images.
Yes, yes. When we run the code,
Yeah,
type
you
of
get
images.
it. Okay, so can we say that this image belongs to Doordarshan TV without signal in 90s? Okay, so in 90s, what was actually there? If signals are not there, then in Doordarshan we are able to see such kind of images. Okay, so at the childhood we assume all these are the mosquito. Okay, flying in the air, kind of. Okay, anyway, so just here just you can see weight. We are talking about the weight. So weight before training. Okay, so I told you during the session, initially weights are randomly generated. Okay, so using some formula you can generate the random weights. Initially weights are random. So just you can see, if we talk about this node, just I'm changing the color. Okay, if I pick this node, all of you just carefully listen. So how many incoming nodes are there at here? How many incoming nodes are there?
784.
784. 784. Okay, and for each edge some weight is there. Perfect. So what it means? 784 weights are there. 784 weights. I'm talking about only this node. If I convert this 784 nodes in the matrix, then what is the size of the matrix? So that is 28 by 28. And what is this matrix? This is image. We can convert the matrix in image form. Okay, so what is the conclusion? So I think all of you are, if you count all these images, these are the 32 images. Okay, and in first hidden layer, here just you can see we have written. Okay, so first hidden layer, 32 units are there, and these are the visualization of weight or visualization about the information is stored at 32 nodes in hidden layer 1. Okay, so here just you can see this is 28 by 28. So in this manner, we can visualize the weight. Now, after training, definitely there is a change in all these images. So I think in one of the cell, I have added that code also. So in the next, okay, any question, any doubt up to this point? Because I didn't saw the messages. Okay, what do you add? Okay, why do add 32 with 25088? Sorry, 25088. So weight and bias, two things are there. So with respect to each hidden unit, one bias is there. Okay, so because in hidden layer 1, 32 hidden units are there, so definitely there are 32 bias. So 25088 plus 32, so that's why it is 25120. Okay, I think there is no question. Okay, fine. So just I'm going with the lab. Okay, okay. So after then, here just you can see we have designed the model. So this is the design of your model, and now we have to compile the model. So during compilation of the model, we had to pass the loss, means on which formula or on which method we are going to compute the loss. So categorical cross entropy, and we are going to use the optimizer. So RMS prop optimizer we will use, and the performance evolution metric is accuracy. Beside it, F1 score, many performance evolution matrices are there. You can go with that one. Now here just you can see, okay, so model.fit. Okay, so training data we have to pass. So x underscore train, comma y underscore train. Up to now, no one has asked the question that what is y underscore train. So I'll explain. In labeled dataset, two things are there. One is the data, and another one is the label. Okay, so x underscore 10 is basically representing the data samples, and y underscore 10 is carrying the corresponding label. Okay, so y underscore 10 is the label. So we are working on the labeled supervised mechanism, or you can say that we are going with the classification. So data as well as label, both we have to pass in the model. Now we go with the testing part. Okay, so here just you can see test accuracy is 0.88, or you can say that 88%. Okay, so just you can see weight after training. So if you see, just you can see previously no information was captured by the hidden units. Okay, but after training, just you can see some kind of information is extracted by the hidden units at first layer. Okay, just you can see some kind of information is there, and this information is better than the previous one. So here just you can see, and here you can see, yeah, here no information is there, but here just you can see after 2 epoch some information is extracted by the model. Okay, so that's done. Okay, so now you can utilize this lab to build any classification model. So I think all of you have a very good idea. So this is a lab on ANN. So now prediction is there. So what you can do, you can pass the sample. Okay, you can pass the predefined sample. Just you match with its what we call the label, and if label as well as result provided by the model is correct, then you can say that model is working fine. Okay, anyone let me know what are these values? Anyone let me know. I think after prediction one vector is there, so anyone let me know what are these values?
Probabilities?
For what?
We are predicting whatever the pattern we are predicting.
So how many classes are there in this problem?
It must be 10.
10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So just I'll explain. I provide one. Who is Ahmad? I'm come to your question also, verbose. Don't worry. Okay. So just you can see very interesting idea. Okay. And there's one more slide I think. Go. Okay, so I'm taking this 2. Okay, so any similarity between 2 and 5? Yes, similarity is there because this section is matched at here. Any similarity with 3? Yes, of course. Just you can see similarity is there, kind of. Okay, similarity with 6? Yes, so some of the similarity is 6 with there. Okay, so how many classes? So each number having some kind of similarity. Similarity may be high, similarity may be low. Even though similarity with 1 and 2 is also there, like maybe this section may match right here. If we talk about 9, so yes, you can see some kind of matching right here. Okay, if we talk about 7, so some kind of matching, this may match right here. Okay, any other number? 0? Yes, of course, this section will match at here. So that's why you see this digit 2 is having some similarity with other class also. Okay, maybe that score is very less, maybe the score is high. ये हो सकता है, it may be possible कि 2 similarity score between 2 and 1 is 10 power minus 3. Okay, similarity between 2 and 3 is 31. Similarity between 2 and this 9 is 5%, something like that. So that's why with respect to each class, score is given. So basically it is showing this similarity score with all the classes. And how we have computed it? So for that, if you see your model where you have proposed the model, in that model you have added the softmax activation function at output layer. I think here just you can see. Okay, so this is your output layer, and here you have use softmax activation function. Okay, so softmax activation function basically return the probability score. So that score is represented right here. Okay, and आपने क्या किया? What we did? So if score is more than 50%, then you put 1, and in rest of the places you put 0. So this is your threshold output. Okay, so I think that's fine. Okay. Okay, now what you can do, complete code I have given, and at the last you can see that first layer size equal to 8, okay, and then another layer 32, and rest. If you check the performance of this model, then definitely it is lower than the previous model what we have proposed earlier. So you can test it. Just all of you run it and share the reason why the performance of this model is poor than the whatever model we have proposed earlier. Anyone? So just any question? Curve pattern, please.
That is not the question, sir. Actually, when you are discussing now, what is the common in
Okay.
2 and 5, that is the curve pattern present in some number, some digits.
Oh, okay.
Sir, explain that verbose now. Actually, what?
Oh, okay. Verbose is nothing. You change the possible values of verbose are 0, 1, and 2. Okay. So in case of 0, you will get the direct output. In case of 1, one progress bar is there. In case of 2, epoch by epoch, you will get the result. Nothing else. So that is not related to any conceptual thing in the deep learning. Okay, वो programming side पे है only. Verbose equal to 1 is default. No, you can go with 2, you can go with 3. Oh, sorry, 0, 1, and 2. 3 options are there.
The 2 for, please repeat. 1 for the.
No, Deepika, just you try it. Just quickly you change. So you
Okay.
can directly see. So I think in 1, you are able to see the progress bar. Let me explain. Where is the verbose? Yeah, here just you can see the verbose is 1. So you are able to see this progress bar. Okay.
Okay, sir.
If you make it 0, then you get only the result, final
Okay.
result. If you go with 2, then epoch by epoch, I think you will get the result. Yes. Yeah.
Okay, sir.
Okay.
Thank you, sir.
If you go with no, Deepika, just we try it 0. Okay. Just you see. So directly you will where is nothing. No. So only execution is there. So generally for the progress bar purpose, we are using that one.
Okay, sir. Thank you, sir.
Okay. So
Some other code related problem is also there. String object has no attribute decode. This is
no, I think that error is there in the JSON file. I think so.
loading when we
Yeah,
want to
just
load.
you leave that one. Just you leave. There is no need of, I don't know. Means yesterday I was given some changes. Okay, so let me either I had to go with the that file is there or not. Let me check. So right now there is no need of this one. I'll check in the drive because this JSON file is not created. I think so. That's why it is showing the. No, this is there. Model.json.
So it's
Maybe
created in our side as well. Model.just and model.h5.
maybe I think model.h5 is also there. Maybe I don't
Yeah,
know. I had to.
this problem. A string object has no
Yeah,
attribute.
it is also happening with me. Yesterday there was no error. Let me check. Otherwise, yesterday I remove it. But don't know. Maybe, but this is not required at this time. Okay, loading and what we call the, suppose you have trained any model, so you can utilize this model.h5 and model.json file and run in different machine or run in different location or run in different places. So while you are trying to deploy the model, at that time you require these two files. So one can be utilized for architecture and another one can be utilized for the weight, previous training weight. Let me check this error. Loaded underscore loaded. Okay, search in Stack Overflow. Maybe we are able to find out the solution.
Actually, they mentioned that dot decode and UTF.8 is not needed. Dot decode we must remove.
No, I think maybe some kind of version issue is there. I think so. But anyway, right now that code is not means too much related with this part. Okay, so hopefully all of you just run this cell, design a model with low number of nodes, for example 8, and definitely in this you feel the performance of the model is poor than the previous one, whatever model I have developed at the beginning. Even though you can write here the code, for example 4 hidden layers. Okay, so for 4 hidden layers, just you write the code at here and you go with the small number of hidden units, then you can feel that training is not proper and the performance of your model is very poor. So even though at Uning, all of you can again go through the complete sheet and you will have an idea about the batch size and what we called okay, about the batch size, about the hidden units, about the activation function and all. Okay, so any other question? Just quickly you type in the chat window or you can ask. Can you tell once again about the threshold output? Yes, so threshold means what? You have to fix the threshold. Means a matching is more than 50%, then you want to define the class, or you are working with the only 10% matching is there, then you can define the class. Let's say I'll take one example. So in place of 0.5, I'm putting it 2. Okay, and just you can, okay, a high match is there. I go with 0.1. Okay, so 0.001, let's say. Oh, even though means 1% is there, then even though, okay, now you can see. Okay, so basically what it is showing that if the matching score is around 10 power minus 2%, then you can decide the class. So in that situation, the same sample belongs to these many classes. But if you put it 0.5, what it will declare? 50% match should exist, then you assign the class. Okay, so 50% match should be there. So let's say 2 classes are there, then 50% probability is there that sample belongs to this class and sample belongs to this class. But if matching is more than 50%, or score or probabilistic score is more than 50% against a particular class, then definitely that sample belongs to that particular class. So from here you can change it, but generally it should be 0.5. I don't know, means in prediction code, I am not able to find out.
Clear, sir. Same like thresholding I'm asking.
Okay.
Okay, thank you, sir.
Okay, hopefully there is no question. So all of you just run this code so that I can continue with my presentation. So many things are there we have discussed. So Dr. Anupriya, can we take a break?
Sir?
Yes, ma'am.
Yes, sir. Sir, actually 11:45 is a break. If you need, you can take and then you can come back, sir. With after 15 minutes. That's
Yeah,
it.
sure. Okay, thank you.
Yes, sir. So I request participants please stay online. Within 15 minutes, again the session will start.
Hello, sir. Can we continue, sir?
Yes, we can.
So this is the next session, no, sir, like reinforcement learning, right?
Yes, ma'am, but even my encoder decoder is not completed.
Uh-huh. If the fundamentals are covered for the
Okay, even the
faculty
gradient.
members,
Okay, so
you will
I'll
guide
cover
them,
the.
sir, because as per session, yeah, because as per the session thing, then we may have to cover that reinforcement learning and gradient descent. It's already 11:51, sir. So
Yes,
only till
yes.
1 o'clock you have time.
So I'll cover the gradient descent also right now, and then I'll provide an introduction about the districted Boltzmann machine. Not go much too deeper,
Okay.
because I have shared some couple of lab also. But okay, in my PPT, the
Okay.
lab lab are also there for the autoencoder. Participants can go with that one. Okay, so I'll cover the
No,
gradient
sir, you
descent.
can
Okay.
kindly use the lab documents, sir. I'm every day at
Yeah.
like the day after, I'm sending them all the PPTs and the lab related documents. So you can share it with me, sir. I will share it with all
Yeah,
of them.
sure.
Sure. Thank you, sir. Please continue, sir.
Yes. Yeah, okay, so just I'm coming to the gradient descent. Okay, so generally in deep neural network, what actually we are trying to do? So we are trying to minimize the loss. Okay, so minimization of the loss. So it is also a kind of optimization problem, and how we can speed up the optimization process. So for that we can use the gradient descent. Okay, so here just you can see two images are there. One is the just you can see here like this, and another one is the like this. Okay, so gradient descent is an optimization algorithm which can be used in the machine learning or deep learning, and objective of this gradient descent technique is to minimize the objective convex function fx. So in case of deep learning, our function objective function is loss, and we have to minimize. So it is the convex one, then fine. Here your minimum point is there, and you have to reach to that point. And in case of non-convex, maybe some kind of UKC in multiple minima and maxima points are there, let's say. And if you stuck in any local minima, I think all of you know about the local and global minima. So just I'm plotting a curve.
Your screen is not visible, sir.
Okay, okay. Just let me check. Yeah, I think now my screen is visible. Okay, so here just you can see. So gradient descent is an optimization algorithm, number one, okay, which is used in the machine learning and deep learning. And the objective of this algorithm is to minimize our objective. So our objective is loss function, and it can minimize. So let's say here just you can see one convex function is there. Just you can see this is a convex, and this is non-convex. Why non-convex? Because multiple minima and maximas are there. So many times what will happen? We stuck in the local minima. So let's say similar kind of graph is there, and anyone can ask, what is this? So you can say that this is a local minima. If we are talking about the whole curve, in that case your global minima is this point, and multiple local minimas are there. Why these local minimas why we say it local minima. So let's say, suppose you are right here, okay, and by applying the algorithm, you reach to this point. And when again you provide some kind of changes in your hyperparameters, then either may you go in this direction or you may go in this direction. In any direction, if you are moving, you are increasing the loss. Okay, so this is also a bigger problem in optimization, because generally the programmer may stuck in the local minimas. So slowly we can talk about this one. So error generally in deep learning actually is that this is the
ఏమైనా ప్రాబ్లం ఉందా? మీరు ఏమైనా చేశారా? మీరు ఏమైనా వెయిట్ చేస్తున్నారా? ఏమైనా ప్రాబ్లం వస్తుందా?
I think Dr. Anupriya, your mic is on.
ఇంతవరకు ఏం
Okay, so in cost function is nothing, it's a error. And how we are computing the error? So we are computing the error by y cap minus y. Y cap is the predicted value and y is the
నేను అస్సలు నాకు
actual value.
వచ్చింది. మీరు
Okay.
చాలా అబోషన్
Now
అయిపోయింది
here just
నాకు
you can see.
సర్వీస్.
Dr. Anupriya, I think your mic is on.
లైక్ అన్ని వాట్ ఇస్ దట్ ఇన్సూరెన్స్ కో ఎందుకు వాళ్ళు మీ దాంట్లో నుంచి కూడా ఇన్సూరెన్స్ కి కాల్ చేస్తున్నారు. చాలా ఇరిటేట్ అయిపోయిందాను సార్. నేను ఇప్పుడు ఏమి ఇవ్వను సార్. నేను
Okay, so now the question is that, suppose we are right here, this is our current position, and our local minima or minima point is right here. So how we can move to this position? Okay, so suppose
I'm
you
really
want to move to the minima point, 3 different kind of methods are there. Okay, so what are these methods? Okay, these methods are you take small steps. Okay, just I'm making it small steps and these to this point. This is one method. So for that you can take one example of, suppose one plateau is there and you at the top of that plateau and you want to reach to the foot means ground. Okay, so various methods are there. What are the methods? You can take a long jump or long step, so then you quickly reach to the optimal point. Okay, if you take the long jump, but the possibility is that you will cross that minima point. Okay, so if you will cross that minima point, then what you have to do again, you have to take the jump. So maybe like this, in this manner you reach to the optimal point. So if you are taking the long jump, you reach to the minima point quickly, but the possibility is that you will cross that point. Number one. Number two, if you take a small step, okay, it will take lots of time to reach to the minima point. This is another way. Okay, so either you take the long jump or a small jump, and in both the using both the mechanism you reach to the optimal point. Okay, but both have its advantages. So this jump is decided by the learning rate. Okay, learning rate, and this is the algorithm for the gradient descent. So what are the algorithm? Randomly initialize the value, update the value. So I think during my lab session I told you that how W is changing. So W dash equal to W minus alpha dW. So dW is nothing, it's a gradient. Okay, it's a gradient, and this constant is alpha. Alpha is known as learning rate, and it's ranging from 10 power minus 4 to 10 power minus 2. Okay, so basically alpha is deciding the step size. Means you have to take the long jump or you have to take the small jump. So here just you can see if the value of alpha is too small, so already this gradient is very small. So small and small multiply, then there is a small change in the weight. So if a small change in the weight, then obviously a small change in the loss. If you take the high value of this learning rate, then what will happen? Weight change is too high, and if weight change is too high, then there may be the possibility that loss may decrease, loss may increase. So intelligently you have to decide the value of learning rate. So in case of gradient descent, every time you change the weight, and you have to repeat the whole thing until unless you are not getting the w dash equal to w. Okay, so this slope equal to 0 means this is 0 multiplied by constant, so 0. So weight old minus 0 equal to weight new. So you have to repeat this process until you are not getting the until there is no change in the weight. So here some examples are there, like here just you can see good learning rate. So just you see this is loss and this is epoch. So if your learning rate is good, then slowly you are minimizing the loss, but number of epochs are high. If you are taking the high learning rate, then maybe sometimes you go down, loss goes down, but suddenly it may high. So this may be the case. Low learning rate, just here you can see. So slowly you are reducing the loss, but number of epochs will increase. Okay, high learning rate, yeah, quickly you will see the change in the loss, but maybe possible that after some time it is stable. Okay, now the question is that how you can find out the good learning rate. So this is a challenge. Okay, so generally you can use the hit and trial method, and you can take other parameters like page size and what we call hidden units, hidden layer, kind of all parameters you can take and try to find out the optimal set of parameters by applying any optimization technique. Okay, so just I'll quickly cover this concept also. So learning rate decay. So I told you that suppose this is a situation and you are at the top of this curve. Okay, so what you can do, you can initially take the long jump, then in each jump just you reduce the step size. So what will happen means so you will reach to the optimal position as faster as compared to the small step size. Okay, so in a faster way you reach to the optimal position. It is better than the such technique where you are taking the long jump or long step size. So in this case what we can do, we can associate the learning rate with the epoch number. So here alpha is directly proportional to 1 upon epoch number. So as and when epoch number will increase, alpha goes down. So this is another concept. So okay, so just I am skipping all the slides so that we can talk about some other thing also. Okay. Okay, so quickly, if you have some question, then quickly you type in the chat window. So quickly I'll take one or two questions over the learning rate and then gradient descent. Anyone, if you have any question, so quickly you type in the chat window, quickly. So due to the time constraint, I am not able to go in much detail. Okay, so because I have to cover this thing in the previous session, but anyhow. Okay, so any question, please unmute yourself or just type in the chat window. I'll take that question and then move forward for other concept like RBM, Boltzmann machine and RBM. Yes, anyone? Yes, anyone. If there is no question, then I move ahead. Okay. Okay, even though if you have the question, then just you can put in the chat window. Okay, so just I'm coming to the restricted. Okay, so I missed one thing where we can use the autoencoder. So I'll quickly come to that slide and explain a couple of application, and then we can go with another topic. Okay, so applications are there. Let's say if you want to compress the data, okay, so at that time you can use the this autoencoder and decoder. Let's say you want to forward the data over internet. So what you can do, you compress the data using encoder and share the weight file and architecture file with encoded data. So at the receiving end, that person will decompress it, number one. Number two, suppose you are working in the information retrieval. So in their domain, a wide use of this encoder is there. Next, suppose you are working in the machine translation or sequence to sequence. At that time, you can use the autoencoder. Or I'm taking one example of image captioning. So in case of image captioning, you have to analyze the image using CNN, and whatever the encoded or embedding is there, you have to pass that encoded information in the LSTM for the generation of the text. So that is also a kind of application where you can use the autoencoder. Next one is there. One more example is there, that is the image denoising. Okay, so what you can do, you can convert you means during training, what you can do, you can pass the noisy images. Okay, so it means first you add the noise in the image, pass that image in the autoencoder, and as a output you will get the original image. So if such kind of system you want to create, you can utilize the autoencoder. With the autoencoder and decoder, you can cluster the data also by providing some kind of changes in the architecture. If you want to reduce the dimension of the data, at that time you can use the autoencoder and decoder both. So during while I have discussed about the architecture of the autoencoder and decoder, at that time you have seen high dimension data is encoded in lower dimension, and again we are converting the lower dimension data in high dimension. So if you are working on the dimensionality reduction, you can use the autoencoder and decoder. So these are some popular application, but even though you can modify the architecture of it for different kind of applications. Okay, so I'm going to just quickly give an overview about the what we call the RBM. Okay, so here just you can see this is the example of Boltzmann machine. So Boltzmann machine was developed by Jeffrey Hinton, okay, the pioneer in deep learning in 1985. Okay, so in case of machine learning, there are two different kind of models are there. One is the generative unsupervised, and another one is the discriminative. Okay, so this Boltzmann machine belongs to the category of generative supervised model. In case of, so in Boltzmann machine, you can see two different kind of nodes are there. One is the hidden unit and another one is the visible nodes. Okay, so here just you see, so these are the hidden units. Okay, and each and every unit is connected with each other. Here just you can see visible nodes are connected with visible nodes as well as hidden units, and hidden nodes are connected with all the hidden nodes as well as visible nodes. So if such kind of structure is there, then it comes under the Boltzmann machine. I'm not going to take this one, just I'm skipping. Okay, so one popular example is there for to understand the concept of Boltzmann machine. So here just you can see this is image of a nuclear power plant. Okay, so in nuclear power plant, just you can see some of the parameters are there, like temperature of the building, then turbine spinning, then pressure inside the pump, etc. So these are the some visual factors. Okay, and your complete system is in a stable state or not. Okay, for that couple of factors we had taken, but beside it some other factors are also there. Okay, and generally we are not considering that one, that like speed of the wind, moisture of the soil, sunny day or rainy day, or it's a winter or it's a summer. So some other kind of parameters are also there. Okay, so only three parameters we are considering, and then whatever these parameters we are not, but we build a RBM, sorry, Boltzmann machine. Okay, and in that Boltzmann machine we pass all the parameters, and we are looking that the system is stable or not. Okay, so if such kind of decision we would like to make, then we can utilize the Boltzmann machine. So in Boltzmann machine, nothing, whatever the parameter are there, with the help of that parameters we are trying to develop a system, and the results, whatever means some kind of computation is there inside that system, because all the layers are connected with each other, and that layers, after modifying the weight, bias and other parameters, okay, so that model or system will declare that your system, the complete system, is in stable state or unusual state. Okay, so this is the concept about the Boltzmann machine. Okay, so two different kind of Boltzmann machines are there. One is the energy based, and another one is the restricted Boltzmann machine. So in case of um, energy based model, so V stand for visible nodes, H stand for hidden nodes, sorry, hidden units, AI, BJ, so Wij is the weight, Bj is the bias, AI is the parameter. So means hyperparameter. So with the help of these parameters, we can compute the energy of that machine, and based on that energy, we can find out the prediction. Okay, so next one is there, that is the restricted Boltzmann machine. So in case of restricted Boltzmann machine, it's a kind of bipartite graph. So here just you can see visible units are there and hidden units are there. So there is only connection between visible and hidden units. Okay, in Boltzmann machine, actually all the hidden units are also connected with each other. Visible units are connected as well as hidden units are also connected. But in case of restricted Boltzmann machine, uh, same kind of units are not connected with each other. So here there is no connection at here, there is no connection at here. Okay, so I think it's too much content. Okay, so basically all this Boltzmann machine is useful in kind of recommender system. So I think there was a challenge by Netflix, okay, for recommending the content to their users. And in that challenge, I think many teams has been participated, and a team which has been utilized this Boltzmann machine, they own the title of they own the title. So after then, suddenly the Boltzmann machine has been utilized for as a recommender system. Means where you want to recommend something at that time, generally the researcher or kind of programmer will go with the Boltzmann machine. Okay, so many things are there. I think I'm not able to cover, but otherwise we have to wait for the uh, RL. Okay, so just I'm skipping all the slides. So after this session, anyone if required, you can write to me and I can answer your questions. So for designing the Boltzmann machine, again, you have to, already we had discussed about the what we called artificial neural network. So in artificial neural network, just you see input layer is there and next hidden layer 1 is there. But in that network, only connection is exist between what we called input to hidden layer 1 and hidden layer 1 to hidden layer 2. But in case of Boltzmann machine, the inter-layer connection is also there. So you have to connect the nodes exist in a particular layer also. And then you try to make the prediction. Okay, so just we can go with RL. So hopefully, I think all of you are well versed in machine learning. Okay, so three different kind of techniques are there: supervised, unsupervised, and reinforcement. In case of supervised, we are passing the label as well as data to the model, and after providing the data, training to model by passing the train data and label, we make the prediction. So best example for the supervised learning is classification. In case of unsupervised learning, so only data is there and your model has to find out the pattern by analyzing that data. Okay, and based on the pattern, your model is trying to cluster or form the cluster for that particular data. So in case of unsupervised learning, we only pass the data. There is no label, number one. Number two, clustering is one of the examples. So take example of in a basket, vegetables and fruits are there. Okay, and now what you can do, you can analyze the particular features of items exist in that basket. So let's say shape, color, kind of nutrients, vitamins, you can take one feature, and based on that features, you have to segregate the item. So obviously the fruit and vegetables will be distinguished, but as you increase the number of features, your division is will be good. Okay, so during clustering you have to focus on the features. In case of reinforcement learning, so in case of reinforcement learning, your model will learn itself from the environment. Okay, so just basic training, you have provided the model and you deploy in the real-time environment, or not real time, you can do the simulation also, and in during that simulation different kind of situations are there, and you have to check with respect to which situation your model is working well, or with respect to which situation your model is working badly. Okay, so if model is working in a well manner, then what you have to do, you have to provide some kind of reward to the model, and if model is working badly, then you have to provide some kind of negative rewards. So based on the positive and negative rewards, automatically your model will learn itself and try to adjust the weight and bias. So in nutshell, we can say that in reinforcement learning, model will learn itself from the environment. But while we are talking about the classification and clustering, we are providing the sufficient data to model, and model will get trained well, and then model is trying to provide some kind of decision on test data. But in case of reinforcement learning, yes, some kind of situations are defined, but many of them are also unknown. So for the unknown situation, model is behaving in a bad manner or well manner. Based on that, rewards are assigned, and based on the rewards, model adjusts the weight and bias. Okay, so I'm not taking this one. I'm coming to the example directly. So here just you can see what is reinforcement learning. So it is a semi-supervised learning model that is used in the machine learning. So semi-supervised means, yes, of course, some labeled data is also there. So you train the model with respect to that labeled data, and some unlabeled data is also there. So in case of unlabeled data, you have to form the cluster, and whatever learning you did with the labeled data, based on that you have to label that unlabeled data. So such kind of things comes under the semi-supervised learning mechanism. Okay, so in case of reinforcement learning, again machine learn through the experience and gain skill without human intervention. So we take one example. So suppose you build a robot, okay, and you build the robot in the earth, and you would like to test that robot in the moon. Okay, so in moon we don't know all the conditions. Yeah, some kind of information is there about the moon, but we don't know all kind of conditions. So in the earth we will train the robot with respect to whatever constraint we have obtained about the moon, as well as in a different kind of real-time scenario or environment in earth also. And after then we pass that robot in the moon, and as per the training, that robot will start working at there, and capture some kind of information about the moon, and accordingly behave and react. Okay, so in case of reinforcement learning, we have to always maximize the reward. Okay, so maybe possible robot is there, and with respect to one scenario 1, okay, let's say minus 40 rewards are there. Scenario 2, plus 20 rewards are there. So if we sum up it, then final rewards are minus 20. So how we can maximize? So in case of reinforcement learning, our objective is to maximize the reward. Okay, so here we are working with the maximization problem. So because many situations are there where a sufficient amount of training data is not available. So if such kind of environment or situation is there, at that time you have to go with the reinforcement learning technique rather than traditional approaches like supervised or unsupervised mechanism. So here, just you can see one example is there. In this example, one grid is there, and in this grid, 1, 2, 3, 4 by 4 grid is there. Okay, and just you can see this robot is there, and robot has to reach to this position. So you can take it or named as robot, or you can say it is a agent. So possible paths are there. So your robot can move from here to here, okay, here to here, then here to here, here to here, and then here. Okay, so if in this manner if your robot will go, then maximum rewards agent will achieve. But let's say this robot may go like or follow this path. So here robot and then here fire is there. So definitely if robot will choose this path, then some negative rewards are there. Maybe they get maybe for the positive one is only 10 and for the negative one maybe it is 100. Okay, so this is one way. Another way is there at this stage again bot move like this. So many paths are possible in this situation. So what we have to do, we have to select such path for which the reward for this agent is maximum. Okay, so in this kind of situation, just you take one example. So here grid is 4 by 4, maybe the grid is 100 by 100. Okay, so in that case you see a huge number of different paths are there. So it's very difficult to find out the deterministic solution for that one. So maybe let's say your agent is moving in one iteration from different path, then score is this one. Then again you uh, with that weight and bias, again you run your agent from source to destination. Maybe because in the previous path overall reward points are very less. So next iteration, your agent will try to choose such path where that agent can maximize the reward. So means 1,000 time or 5,000 time when you run your model. Okay, so after some time your rewards will be maximized, and that is the final solution for your particular problem. Okay, so here the goal is to get the reward, okay, that is the diamond, and avoid the hurdles, that is fire. So two things are there, diamond and hurdles. If diamond is there, so whatever reward you have earned, um, there is some kind of reduction. If you reach to the diamond, then your reward will be increased by some amount. So in case of deep reinforcement learning, some important points are there. One is the input, another one is the output, and then training. Okay, so the input should be an initial state. So actually in deep reinforcement learning, we are using the word state. Okay, so one particular state is there, against that at that particular state some input is there, some activities happen. So according to that things, your agent will move to the another state. So something kind of things are there. So input is there, initial state and intermediate states and final states. So these are the different kind of states. Output, there are many possible output as there are variety of solution to a particular problem. Okay, so if you are taking the example of chessboard, so 8 by 8 chessboard is there, and if you start moving from one corner to another corner, multiple paths are possible. So training is based upon the input. The model will return a state and the user will decide to reward or punish the model based on its output. This is the important thing. So training is based upon the input. Okay, number one. Number two, the model will return a state and the user will decide to reward. So right now, just you can see here, this is initial state. Okay, some activity happen. If this agent will move in this direction, okay, so new state, here it will move another state. So suppose your agent at this state, then you have to punish. If your agent at this state, then you have to provide some kind of reward. Okay, so next point, model keeps continue to learn. Okay, so continuously your model will be in learning state, and what the best solution is decided based on the maximum reward. So whatever a set of states for which the reward is maximum, that is the output. Okay, so RL versus ML, this is also one of the important thing. Okay, so in case of RL, you have to make the decision sequentially, always remember. At each and every state, you have to make the decision. In case of supervised learning, as there is no such kind of thing, state or activity kind of thing. Just you have to pass the input, okay, and start the machine, and whatever output you will get, you compare with the input if it is matched. Okay, comparing means if we are working on the kind of what we call the digit classification. So in that case, if origin text input and the sample input both are the same, then you can say that classification is correct or not. Okay, so in simple word, we can say that the output always depend on the state of the current input, and the next input depends on the output of the previous input. Okay, so sequentially your agent will visit the different kind of state, and in each state different kind of input is there. So based on that state and input, your model has to decide. Okay, your model has to take the decision. So if you try to understand this reinforcement learning, so the best example is chess game. So in case of chess game, well, maybe possible that one move you made, okay, so next move is always dependent on the previous move. Those who are playing the chess, so they know it very well. Okay, so yeah, of course, in case of chess, opponent party is also there. So based on that, we have to move. But if we assume there is no opponent, even though we have to make our second move based on the first move, and next third move is also dependent on the previous moves. Okay, so in this manner, we are actually playing chess in the real life. So similar kind of thing is also applicable in case of reinforcement learning. So here just you can see again difference between machine learning supervised versus reinforcement. So supervised learning is teach by examples. Okay, so during training of the model, we will pass the label as well as we will pass the sample. Okay, so examples are there and your model will learn, and that's fine. In case of supervised learning, because examples are there, so with the help of examples, model will learn. But in case of reinforcement learning, teach by experience. Okay, so here just you can see two images are there. Okay, so basically one there is a sofa and one small kid is there, and this kid wants to reach to that sofa, okay, for playing purpose or something else. Okay, so sometimes maybe kids start walking, he fell down, maybe he will walk on knee, something like that. So sometimes maybe possible he reached to the another corner of that sofa, but even though he is not able to, now the question is that how he take a seat in the sofa. So again he move back or left or right. Maybe possible that the baby will go in like this manner. Okay, so in a single shot or with the minimum move, he reaches to this sofa and take a seat. So this is the best one. Okay, so many possibilities are there, and you have to select the best possibility, and the best possibility is always based on the reward. So for each activity or for each solution, some rewards are there, and whatever the rewards are maximum with respect to which activity, that is the best solution. So here this baby will learn from the environment. Okay, learn from the environment, and after then the baby is able to take the seat in the sofa. So this is the thing. Okay, so here just you can see. Okay, so one open question, just okay. I'll skip it. Okay, so this is a kind of diagram where you are able to distinguish deep learning and DRL. Okay, so in basically in deep learning, or we are taking the supervised deep learning or classification example. So environment is there, collect the data from the sensors, sensor data is there, extract the feature, okay, and convert that feature, and then apply the machine learning, some kind of knowledge is there, okay. So in case of this deep learning or ML section, we come or we work only this zone. Okay. In case of reinforcement learning, yeah, of course, we include all these steps. After then, okay, two more steps are there: reasoning, why it is happening, and you have to make the plan, and accordingly you have to take the action. So you have to collect the knowledge, then why you have to check why this is happening. According to that region, you have to plan, and according to planning, you have to take the action and effector, and then again you move to the environment. And the whole process is repeated again and again until you will not get the maximum reward. Okay, so here just you can see the reinforcement learning framework. Okay, so this is your agent, okay, and this is your environment. Okay, so you take some action, definitely you will be the another state. Okay, so then again according to your state you will get some reward. Okay, reward may be positive, reward may be negative, and you are in the another state, and again you have to take the action. Okay, so in another state, and accordingly you have to be awarded, okay, based on your function, and you will be definitely in the new state, so you have to repeat the thing for the certain number of epoch. Okay, so just yes, so here you can see major component of an RL agent. Okay, so number one is the policy. So every time when you are working with the reinforcement learning, you have to define the policy. Okay, so what is the meaning of the policy? Agent's behavior function means agent behave like this, then what will happen? If agent behave like this, then what will happen? So here behavior means kind of movement, or what kind of action he will take. So all such kind of things we have to cover in the policy. Next one is their value function, how good in each state and or action. So value function is a kind of reward. Okay, so in each state and or action, so for each state or for each action you have to define the reward. So you can combine both of them, or you can take it individually also. Next one is the model. So agent's representation of the environment. Okay, so suppose you are working with the chess game, different kind of environment is there. If you are working with the cart pool kind of problem, environment is different. If you are working with the what called autonomous car, different kind of environments is there. So you have to set the environment with respect to your problem, and for the individual problem you have to define the policy and reward also. So here just you can see some sequence I have given. So S stand for state, A stand for the action, and R stand for the reward. So at state 0, you had taken action A0, then reward are 1, and at state S0, after taking action A0, you move to the state 1, then this is the sequence. Similarly, you may be possible that you will reach to the terminating state, terminal state. Okay, so with respect to each state, with respect to each action at each state, some kind of rewards are there. And in RL, our overall objective is maximize the reward. Okay, so I think, okay, discount factor, discounted future reward. So such kind of thing is also there. So means here just you can see future reward equal to RT. Just you are summing up the reward. But discounted future reward, you can add one factor gamma, and it is very small. Okay, so you can increase the gamma and you can change the reward value in each iteration. Okay, so here just you can see, okay, so reward plus 1 at 4 comma 3 and reward minus 1 at 4 comma 2. And here this is one problem, just you can see a silent greedy policy. So 4 actions are there. One is the up, down, left and right. Okay, next one is there, that is reward. So for these two cells, reward is given. And reward minus 0.04 for each step. So when you take the step, okay, so minus 0.04 reward is there. Okay, so how you can maximize the reward? So you have to reach to this position in minimum move. Okay, if this agent will start from this state and reach to this corner or reach to this cell in minimum move, at that time only maximize, at that time this agent will maximize the reward. Now, what are the action? So in a particular state, the agent will move either left, right, down, and okay. So 4 possibilities are there: up, down, left, and right. But start position at the corner, so we have to put some kind of constraint that there is no left move or down move. Okay, so now maybe possible that your robot will start from here, reach at here, then minus 0.4, then move here, then minus 0.04 again, then minus 0.04 again, then minus 1, and then move to this location. So this is minus 0.12. This is one way. Another way is like this. Okay, another way like this, or maybe this. So many possibilities are there. And in my opinion, the best solution to reach to this one, I think this one, because in this case there is this minus 1 reward is not there. Yeah, but for each movement minus 0.04 reward is there. So but anyway, this is the optimal way to reach to the another corner where the reward is +1. Okay, so here just you can see what is the strategy to achieve maximum reward. We can learn the model and plan. We can learn the value of action state pairs and act greedy or non-greedy. We can learn the policy. So this time maybe these are the strategy and you can follow anyone. So here just you can see. So here we go with the shortest path policy. Why shortest path? Because here for each move some negative rewards are there. So what it means, from this position I have to reach to this position in by using the shortest path. Okay, so two possibilities are there. So 1 2 3 4 5, 1 2 3 4 5. So two paths are there. So in this case, shortest path policy we have applied. Okay, so again, just here, just you can see reward is -2 for each step. So how you can maximize? So again, policy is same. Now here, just you can see one more example of reinforcement learning, that is the cart pole. Okay, so just here you can see we have to balance this cart pole. Okay, so different kind of other factors are also there, which is related to mechanics. So theta, m, velocity of the car, force, friction, kind of. So we are not taking all such kind of things in the consideration right now. So here the objective is goal. So balance the pole on the top of a moving cart. So this is our goal, and we have to okay, so cart is moving, and we have to balance that pole. Next one is there, what are the state? So as a one state, pole angle, angular speed, cart position, horizontal velocity. So all these are the factors. Okay, and if there is a change in the any these factors or change in the state, then definitely you are not able to balance that pole. Action, okay, so action is horizontal force. So I think in childhood we play one game like one pole is there and we are moving, and then we are trying to means balance the pole in our palm. So for that we are also moving our palm to balance the pole. So same kind of thing is also there. So while we are trying to balance the pole in our palm, then we have to apply some kind of horizontal force, and by applying the horizontal force we are able to balance the pole. So same kind of thing is also there. Okay, so that's why it is written that horizontal force to the cart, and reward is at reward is 1 at each time step if the pole is upright. Okay, so for each time step, if pole is upright, then you have to means your model will be divided by 1. Okay, so actually what you can do, divide, and it is not mandatory to go with divide only 1. Okay, you can take any value. Okay, and maybe different kind of mistakes a human can do. So according to mistakes, you can also assign some negative reward. Okay, so maybe this mistake is there, then only 0.5 is there, negative reward minus 0.5. Maybe this kind of mistake is there, then you can go with minus 10. Okay, so depending upon the mistakes, depending upon the state, okay, you can design or develop the policy, and you can also notify the rewards. Okay, so one more example, just I'm skipping. Okay, so one more example. So one robot is there, and the objective is to pick an object of different shape. State, draw pixel from camera. Okay, so these are the step. These are the states. Means one camera is associated or attached with that robot, and whatever the image that robot will capture, that is the different states, and action, move on. So grasping and moving the arm. There are only two actions. So that robotic arm can either move the arm or can catch or grabs the product. Okay, so if it that arm pick the object, then it is positive rewards. If not able to pick the object, then it's negative reward. Okay, so just quickly I'll cover the terminologies used in the reinforcement learning. So one is the environment. Okay, so scenario is a young child is handed the TV's remote control at your house. So generally everyone having the TV remote now. All the TVs are operated with the remote. So environment is the house, okay, and within that house a specific area where TV is there, then remote control and the child. All three things comes under the environment. And in this scenario, child is the agent. State, the current unaffected state of the house or environment. Okay, so this is the state. And actions, the child starts to experiment with the remote. So generally if a small child is there, so he start experimenting with the remote. Next state, the effect that the experiments or action have on the environment results in a new or next state. So when you just you play with the what we call remote, so maybe TV will on or TV may be off, or let's say you want to open the YouTube, maybe different kind of various situation and states are there. So this is one small example. Okay, so just I think we can leave it. Okay, yes. No, I think no, I think we are not. I'm not able to cover some other things. Okay, so it is good if we next 5 to 7 minutes is left. So what we can do, we can discuss, because it's difficult to means go with some other terms like DQN, DQN, NDP policy. So it's very difficult to cover any one of them. Okay, so we can utilize the rest of the time for the discussion, and we can bind the session. And if you have no, already I have 3-4 more labs, but due to the time constraint, I have to withdraw that lab. But in my PPT, that labs are provided, that lab links are there. So in that lab, 4 labs are there. One is ANN, then normal autoencoder, then deep encoder, then RBM lab is also there, restricted Boltzmann machine. So what you can do, you can practice at your home. And if you will face any challenge in that lab, then you can write to me also. Yes, Dr. Anupriya, you want to say something?
Nothing, sir, nothing. Just for the participants. Participants, if you have any doubts to be clarified, kindly get it clarified with us, sir. We are left out with the 5 more minutes.
Yeah,
no, we don't have the session. Yeah.
Yeah.
Participants, if you have any doubts, you can get it clarified. You can post. I know sir was trying to explain then and there. If you have any specific doubts, please ask. Otherwise, I can conclude the session.
But sorry from my side, actually, due to the time constraint, I was not able to cover all the things. So on the day when I saw the brochure, and so many things are there. So just I scared means how we can cover all the points. Okay, yes, please.
Sir, when we compare autoencoder algorithm with the reinforcement and YOLO algorithm, which is more effective?
No. YOLO is a kind of object detection algorithm. Okay, and reinforcement is different thing. Yeah, with the help of reinforcement, you can detect the object also. But I don't think so. There is any similarity. No. So YOLO is the extension of CNN, nothing else.
Yes, sir.
है ना? But yeah, of course, you can utilize RL for the object detection. You can utilize.
Okay.
But for that, you have to make the policy, you have to make the state, kind of. So all such kind of things you have to define, and then you are able to.
So there is one question in the chat. Please share some good resources for DL in image processing for beginners.
Okay, but resources, I have lots of resources, complete one bunch is there. But before that, I would suggest just you first you try to study the reinforcement learning only. Okay, first of all, and a couple of source codes are available in GitHub, and you try to experiment with gym environment, and just you try to solve this card pool game, deep freeze lake. Some specific problems are there related to reinforcement learning, and for all these, for the resources, you can visit the GitHub. So at there you will find the PPT, you can find the books, you can find the code in Python also. All such kind of things you can find from there. If you require, then I have to search and send to you. Nothing else.
Thank you, sir. You had discussed in detail the autoencoding, and for the resources, like we could see the different resources shared by you. And thank you very much, sir. It was really helpful for us. I mean, for all the participants, I believe.
Okay.
And the second was faculty members. They were asking some questions in the chat, and then and there it was also answered. Thank you very much, sir. Thank you for the nice session. And we look forward to associate with you further.
Yeah, sure.
In case if there are any specific questions asked by,
yeah, I'm sharing my email ID.
I can share the mail ID also to them.
No, I'm sharing my email ID. So
yeah, please.
Yeah, so anyone can write. Okay.
Thank you very much.
Okay, thank you, ma'am. Thank you. Okay.
Thank you very much. Participants, we have taken the feedback of the speaker. So the next session, in the afternoon session, will be on the YOLO model. So we will meet by 2 o'clock. Please join the session exactly by 2 o'clock, because some people then living in between and coming. We do have the attendance. We are not strict, but at the same time we need to we have to follow the what is that, the discipline what we are looking for in the FDP attendance. So please try to join on time. That will be Santosh, who is the Associate Dean Research, and he will be focusing on YOLO model, as well as sir will also be conducting an hands-on session. Okay. Thank you all, and we will meet again by 2 p.m. Thank you.
Right, width and height. So the image width and height should be in the terms of multiples of 32. Right? So you need to keep this point in mind. This is because when you work with less dimension images, the content in the image cannot be read efficiently and can be communicated for the sake of classification or segmentation. For that reason, you should keep it in a standard size. Next is the classes. The number of classes you need to modify it to 2 because we are only working with 2 classes from the image. So we are talking about 2 things in the image. Those are tiger as well as peacock. So we are only having 2 classes. So that's why change the value to from 80. Right. Next is you need to change the filters to 21. The value of filters to 21. Not all filter parameters are to be modified. It is required to keep in mind that wherever convolution is there, then you should modify the filters value to 21. And you see where a convolution column is there in the file, you need to modify the filters value to 21.
One doubt. You have mentioned that altering the configuration file we need to alter from where we need to download and where we need to upload.
Yes, madam. These configuration files are already sent to you, madam. You can get it from that zip file.
Yeah, I got, sir. Then where I have to upload the same drive I have to upload?
You should upload to your Google Drive. You should upload not only this configuration file, entire folder should be uploaded to Google Drive.
Till this step I did, I got it was perfectly working. So that altering dot configuration file, it was mentioned, no, like you have to open the file using any editor. So,
yes.
How I have to open, sir?
You as it is already available in your Google Drive. In your Google Drive, there is an option to edit your file using online Google Drive text editor. So you can check it from your Google Drive, please. There is an editor. So right click or double click on that file. Let us say you want to modify your configuration file CFG. So go to the file location.
Okay.
1 minute. I am going to that file location.
Okay, sir.
Right here you have under YOLO V4 folder, you have wildlife.cfg. You double click on that.
Okay, sir.
Then it will ask you to edit with the editor. So you see open with option. It is asking you to connect to the text editor.
Okay, sir.
So with that, you open your configuration file using the text editor, and there you can actually modify. It is opening, please. Yes. Now is it possible to see this file?
Yes, sir.
So you see, madam, here batch value is already assigned to 64. Now you see this file is ready to use file. Please try to understand that this file is a ready to use file because the time given for the session is less. So that's why everything is readily available. As you see, batch is 64, subdivisions is 16, width and height of the image is fixed to 416. Right? The number of channels are made 3. So channels are nothing but the number of what you say feature layers. the number of feature layers, feature maps. So that is 3. And the values that you are seeing here, the maximum number of batches that you are taking is 600, right? So, and you see that the step values are for 4800 and 5400, which is 80% and 90% of max batches, right? And also you see the filters value should be changed to 21. Now you see Control F, filters, right? So which filters are to be modified? We are notified there. Please check it, right? So you see, so once you do all these things, right? Once you do all these things, simply click on this save, right? Which was not saved earlier. You click on this save and close it. So obviously the modifications will be appended to the Google Drive.
Sir, which filter you have changed? That is the convolution batch normalization below this.
Yes, so the filter that I have changed, you can see from this 1 minute.
Yeah.
You see this, the filter that I am changed.
It's a 21, I know, but
Yes,
in
values
this
that are
text
changed
file, it's a
are
32.
you see that to be changed in the before YOLO layers. What are all convolution layers that are there before YOLO layers? In that you should change the filters to 21.
No, I didn't get you, sir.
You
Just a
have seen
minute.
the file, right? You have seen the file, right?
Yeah, I am in front of my file.
In
But
that file, if you observe that file, you have these things, right? The convolutional, right? Shortcut,
right,
convolutional route, right?
it's
So there
32.
you have, there is YOLO, there is convolution followed by YOLO.
Okay.
You please check it. Convolution followed by YOLO will be there. There you should modify the filters value to 21.
Okay, 1 minute. Convolution.
Before each of the YOLO layers, please try to understand. There are 3 convolution layers before each of the YOLO layers. So you need to modify those filters. Remaining filters you need to keep it as it is.
So 3 places we have to change, no, sir? 3 places.
Right, 3. In 3 locations you need to change.
Before YOLO.
Yes, before YOLO. Fine. Madam, can I continue?
Yes, sir. It's
Yes.
already 21. It's already 21.
Right. Now that's what. So now next is you are creating the names file, which is nothing but the class names that are present in the image, right? We are dealing with only 2 classes, tiger and peacock. So we are using the names here. This is for the sake of the classifier to associate the class numbers with the class names that are present in the image, right? So corresponding objects are actually classified first, and then the bounding boxes are predicted, right? So now next file is what you are doing is you are also creating a data file in which you are specifying 5 things here. The first one is the number of classes, and the next is the where the training data is actually residing, where is the test data that is actually residing, and then the names of the classes and a backup location, right? A backup location where you will store the weights of the network, where you will store the weights of the network that is last modified. Please try to understand whatever weights that are last modified, that will get stored in that backup location, right? So now here also I am not executing this particular cell because these weights are already been made available in your folder, in your darknet folder. These weights are already available, so that's why I am ignoring this cell, right? I am not running this. And then these modified files are already there because which we have done, right? Now which we have done through text editor, those are already made available, right? And the next step is you are making these files compatible with Unix environment because the destination operating system is Unix. So that's why what you're doing is you're making the files readily available to run in Unix environment. So that's why first you need to install this DOS to Unix library and then you will convert, right? That's why you are first getting that library and then you convert. So these are the to convert each and every file to these 5 files are required for the sake of execution. So you just uncomment it and run them. So you can understand if you see more than 5 steps in the executed environment here, that means there is some error that you have done during the folder creation process. So that is the most important thing, right? And then once everything is ready, your train data, test data, locations, your configuration files, your class labels, and everything is available. Then the next thing is use the model, deep learning model in order to train, on your data set, right? So you have already downloaded the weights earlier. Use that weights. So this is the weights name file of the weights. So YOLO v4.convolution.137. So you are giving the parameters as train. The command is train the data set and with the corresponding configuration files, right? So now I am starting the training on my data set, right? So now as there is a option called don't show, it is not showing us. Then what you are doing is you are taking the backup of the weights, which are actually now getting modified on in the model, right? You have used the pre-trained weights and those weights will now get modified because you are using in the learning process. So the most fundamental point that everyone needs to know is when learning happens through neural network, weights get modified, right? So that is the learning part that actually occurs. So that's why the modified weights are to be taken as backup for the sake of future purpose. So now here already earlier weights for 200 iterations are already shown for YOLO v4. If you want to have those weights, you can download or you can use the existing backup weights. And now here in order to whenever you do machine learning or deep learning, once you learn and get the model, the next step is to find out the performance of your model. So in order to find out the performance of your model, right, what you are doing is you need to do the prediction, right? So before doing the prediction, what we are doing is we are also calculating the mean average precision of the trained model. What is this MAP? MAP is in this object detection context is the comparison between the bounding boxes that are available in the image uh, from the training data set and the bounding boxes that are given by the after training. So what we do is we will calculate this MAP value, right? Right, you see here this MAP value, as you see, right? IOU threshold. We are talking this MAP in terms of IOU. IOU is intersection over union. So if the overlap between the trained between the bounding box in the image dataset, trained image dataset, and the detected image dataset, if the value is uh, more, the percentage overlap is more, it means the prediction is correct. So here during training, it is obtained that it is only 50%, right? So now can this 50% solve our purpose? So that we are checking in terms of test image. So we are passing the test image, please. So the name of the test image that I will use here is a different one, because in order to show you the the predictions of the bounding boxes in a better way. So I'm using another image, tiger peacock test.png. 1 minute. I will use this. Tiger peacock test under PNG. So yes, so we can see the prediction that will now happen. As you can observe, it is taking time. Why? Because onto the test data, the model should convert the image into grid cells and move the do the convolution part on the grid cells, and then find the objects in the image and provide the class label to that image. So, and that after providing the class labels, you should also provide the dimensions of the object in terms of bounding box center as well as XY coordinates. So this will take time, right? So you may ask a question. You said that YOLO V4 is the fastest and efficient one. Yes, it is true, but the machine should be of high configuration, wherein your data set and your your deep learning model are actually running with you, right? We are taking the support of cloud machine, so that's why we need to wait until the response is obtained. So as you see, GPU is getting used.
Sir, in between, there's a question. Sir, in C, you have mentioned no, that altering configuration file, then creating dot names file.
Yes,
So,
yes.
sir, what I have to do? We have to change anything that dot name same as configuration file. We have to change anything in
No,
dot
no
name.
need, madam. No need. As of now, nothing to do, because I have shared all the files which are already altered earlier for the sake of running this model.
Okay, so we can continue running from the next step onwards.
Yes,
right?
yes. No, the only thing that you need to take care is correct uploading of your zip file. That means the contents of the zip file.
Yeah, till that step it is working properly, sir. Now I am into 13, step 13.
Fine, fine, good.
Meanwhile, sir, I just want to ask a question.
Yes, madam.
That is, can we use this method or this YOLO object detection for detecting the small object? Like my problem is to detect the anomaly in soybean.
Okay.
So the soybean seed is very small, you know.
Yes.
And the problem is like the overlapping might be there.
True, madam. When you say you want to work with soybean with YOLO, so the image sizes should be taken into consideration in such a way that the object is detectable. Understood? So that's why the sliding window, there is a first traditional technique called sliding window, which asks you to find out the size of the sliding window in iteratable fashion. So which sliding window is best suited? That sliding window dimensions are actually used. So the same sliding window dimensions you need to set for the sake of creating the bounding box here.
Okay, sir. So, but in your opinion, is it the appropriate, model to detect anomaly in soybean? I mean, YOLO-based model?
It should be actually integrated with image segmentation concept so that the instances that you would like to identify as anomalous are to be first segmented.
Mhm.
Okay, so segmentation followed by detection of that particular area. So there is a alternate model called YOLO Tiny.
YOLO tiny. Okay.
Yes, you can use that YOLO Tiny deep learning model for working with small data sets, let us say small dimension data sets.
Okay, YOLO tiny.
Yes.
Actually, we tried with ResNet. With the deep learning model ResNet, but
Yes.
the limitation is that is the number of object. Our model can't count the number of object more than 100.
Okay. So in that case, what you should do is you should modify the network architecture in such a way that the images, right,
Okay.
are iteratively taken.
Okay. Right.
Yes.
That might be possible, right?
Yes, madam. This is
And
taking 1
what
minute,
we can
madam.
do
I am
for
actually 1 minute, please. I will answer your question. I am actually finding it is taking time. Yeah, it started. Madam, please continue.
Okay. Sir, we have the second problem, that is overlapping problem. So,
Fine.
can you suggest any, solution for this? Because the small seed normally overlapped. Whatever precaution
Overlap with
could be
what?
taken.
Overlap with what?
Overlap with each other, like one seed with other seed. So
Yeah.
it's not possible that that seed can be identified clearly sometimes.
Then, madam, I suggest you to go with what is called as RCNN first. Before working with YOLO, you please work with RCNN. Why? Because in
Sir,
RCNN,
RCJ, right?
yes, in RCNN you have selective search mechanism.
Okay, actually we
Selective
did,
search actually searches or find out the region of interest on the basis of colors.
sir, we already did with RCNN, but
Uh,
the problem not solved. So we were searching for the edge detector as well, the proper edge detector, so that we can segregate some.
so in that case, madam, in that case, you go with the better option would be you first would do segmentation. Okay,
Right. Mhm.
right, segmentation, and you apply the concept of histogram equalization on the images.
Okay.
Then what happens if you do histogram equalization, and also you should do histogram equalization in a very careful way, because when you say overlapping, the region you would like to make it different should be identified first, and that region should be converted. Region should be histogram equalized, so that the brightness will be improved, contrast will be improved in that image, in that region.
Okay, I will try.
Please,
Thank you.
madam. We will continue now. Now
Right.
you see,
Thank you very
madam.
much.
Fine. Now we have actually predicted the bounding box for the image. So you see, prediction has happened successfully here. It has taken time, but still it has happened. Now we will display that result. Yeah. So what happened? It is not visible. I think why so? It will show you, no problem. It will show you. We'll also run this on the videos, bounding box on the videos.
Sir, in between that 15th step, we need to convert the uploaded file in Unix format that it is already commented. Should we need to run that?
No, when it is commented, it means you need to uncomment when you run for the first time.
First time, okay.
After running for the first time, you should once again comment.
Okay, sir, okay.
Yes, madam. Yeah, this prediction of bounding boxes is over. So what we do is we will go to this location. We will go to this location and we will check, right? So it is in darknet folder, right? In the darknet folder. We will change this view format so that we can see the time and date also perfectly. Peacock Tiger 5, I think. Taking result AVI. Yeah, it has modified the predictions. Once again, I would like to check it 1 minute with images. What we do is Peacock Tiger 5 we will take. That is better. Peacock Tiger 5 instead of this. Yeah. Go to the image Peacock Tiger 5. We will see on this. We'll predict on this image. Yeah, this image is quite is correct. I think it is predicted. We'll check on minute and see the displayed result also here. Yes, yes, you can see this, right? You can see this. Now you'll see the timing also here. Now you can observe the time, right? You can refresh your drive so that will be shown with the time modification. Will come down. Yes. Yes, prediction file. It is loading the image. We can open this. 1 minute. Yes. You open this predictions file. You can see the image. Is taking time. Yes, you see. Is the prediction visible to all of you?
Yes, sir.
Yes. You can observe the objects in the image are predicted in the correct way. Tiger, peacock, right? Multiple objects are also predicted, right? So the advantage, which is of course a disadvantage also, but we cannot see it as a disadvantage because you use threshold during bounding boxes assignment so that there actually you are only seeing how many bounding boxes here 1, 2, 3, 4, 5, but actually YOLO has given us too many bounding boxes in this image, which are actually filtered in a two-step process based on threshold values, right? So what happens is on the basis of the trained image bounding boxes labeled with bounding boxes during training are actually compared in that MAP, this is what is actually happened. That comparison takes place and filtering occurs so that the unrelevant or uninterested bounding boxes are actually filtered out for the when prediction is actually shown. That's why we are only seeing the actual bounding boxes for the available objects. So there are only two objects here, or two classes that are tiger and peacock. So those are actually predicted. Now in the same lines, we can also move ahead and see in the video also the prediction has occurred. You see at 2 p.m. now, the result is actually now visible clearly. In the video also, video frames also, bounding boxes have been attached. You see, a corresponding confidence score is also shown. We'll run this video 1 minute. Right. So you see how the confidence score is modifying. You can observe. Right. You can observe here. So this is a very faster way of making darknet model run on the image as well as the video for the sake of object detection, right? You see frames per second are actually taken into consideration. So average frames per second is 11.9 at any point in time, and for every for every set of frames, the YOLO algorithm is actually detecting the objects in terms of its confidence scores. So finally, what happens is this average precision is actually taken into consideration for the objects in the images, and that corresponding average precision is shown. Right. So now, please, this recording will be made available with all of you. There is no issue, no need to panic. The only thing that you need to keep in the mind is do not download this weights file, YOLO V4 weights file, and do not modify any configuration files which we have sent you. Anything, no need to do no need to change anything. And also the third thing is do not clone this darknet GitHub repository, because this darknet is already available with you, right? So this is all about hands-on on YOLO. Somebody has parallelly working with me. Anybody has got the results, madam or sir?
Sir, I got the result, but without bounding box.
Without bounding box.
Right. I changed the just a minute. In the 19th number of a code column, predicting bounding box for new image. So I
Yeah.
put there the image is peacock underscore tiger 5 PNG, right?
Yeah.
And after that, in the number 20, display the result, where I again change file is equal to peacock underscore tiger 5 PNG. It successfully plot the image, but without bounding
Madam,
box.
you should not change the file name as peacock underscore tiger 5. In the display section code which you are seeing on the screen, you should not modify the name of the file, because that is the name of the file that will be provided for the test image after prediction.
Okay.
So you should not modify the name of the file. That name is now given after prediction to the tiger underscore peacock 5 or peacock underscore tiger 5 file. Okay.
So in both places, the same. I mean, just show the 19th one, sir, please.
Yes, madam. You see
The
here
19th one.
during prediction part, you should specify which is the test image for which you would like to predict the bounding boxes.
Sir, can you scroll a little bit? Yeah, peacock tiger PNG. Yeah. I put here this one, right?
Yes.
And I run this code successfully. It's successfully run. There's no error. But
Now, if you
when
see below in the below code, you are actually assigning a name to that predicted image.
it's a predictions.jpg,
Some
when I
name,
run,
some name, right?
yeah, but when I run this code,
Uh,
then a error occur in the line number 14. That is show underscore image is equal to this is cv2.cvt color.
yeah.
Here line comes and error occur.
Line comes. What is the error, madam? Please let me know.
Error is this is OpenCV 4.12 IO OpenCV module. Something like this assertion is failed. Source is empty.
So the session is failed. It means your GPU session is inactive for so much of time. That is the
Okay,
problem.
so once again I run all the codes.
If you once again run, what happens is your cloud storage disk space will be occupied. That's not a problem. What you should do is, madam, you should go to the edit section.
Edit.
In the
Okay,
edit
fine.
section, there is a menu called notebook settings. Click on
Right.
that, and you once again select GPU here.
Right.
And click on save.
Click on save. Okay.
And then you run from, let us say you run from the 16th point, 16th point training.
Convert the uploaded file in Unix format.
No. After that, train on custom
okay.
data set.
Right.
Please follow the instructions and do the same.
Okay, fine, sir. I will.
Yes, madam. Any doubts, please?
Can you please summarize, sir, what are changes actually we should do in the code actually?
Well, once again, I will in a faster way. I will please move these steps and also do and explain what kind of modification that you should do. Yes, if you are downloading the darknet, if you are cloning the darknet repository for the first time, and if you are working with the uh, number of objects in the image to your required number of objects, then the alterations are to be carried out on the basis of steps available there in the configuration file. Right? So now the first thing is you should upload everything into your Google Drive, and you should mount the drive into the Colab environment, and then you should change the repository to the location where your folder is residing. Your folder is residing. Yes, is my voice reaching you?
Sir, once again the same error occur. Even I run the GPU once again.
So what you do is, madam, go to the runtime and then restart the runtime. No issue.
Okay, fine.
And when you restart the runtime, you should start with the first step.
Okay.
Yes. So please allow me to summarize this. And the next thing is, when you move to the folder location, you should check whether the darknet is available in the folder. As darknet is already available, no need to clone your GitHub repository for getting the darknet model, the deep learning model. So I have not run that step, and then immediately what we are doing is we are moving that what you say darknet to be under this folder, which is already there. So you are listing what are all the files and directories available under the darknet, and then you are activating your GPU and CUDA environment for neural network and OpenCV, right? And you are making it as an executable file. You're making it ready for the sake of running. Right. After that, what you are doing is, as this is happening in the Unix environment, you're changing the mode to be executable, so that packages and everything configurations which you have already obtained are ready for usage. Now, then what you're doing is you're reading your repository data set and making it 80-20 for training 80% and 20 testing. So you are seeing percentage test, and you are opening in the right mode. So you are reading and you are, of course, writing the what is the steps, right? Whether it is train or test. So once you do this, the most critical and important step is alteration. So the configuration files alteration, names files alteration, data files alteration. So the important thing is this configuration file alteration, because it all depends on the image data set and the number of objects that are present in the image data set. So that's why the values are to be modified accordingly. So here we are talking about only two classes. So based on that, the batch values and the subdivision values are actually shown here. If you want to be more specific in terms of these alterations, I will surely share the formulas for each and everything which you should apply for getting these values, right? So, and the most important thing is these filters, the value of these filters. These filter values are to be equal to, made it to 21, which are actually present under convolutional convolution layer in the file. These convolution layers are before each YOLO layer in the configuration file. So only there you should modify the filters parameter to 21. Remaining filter values are to be kept as it is. So then you need to alter the names file. In the names file, you will specify the names of the objects that are to be identified, or the class names, tiger and peacock. And then you are using the data file. So in this data file, you are specifying the most important things like number of classes, train data set location, test data set location, and the names, as well as the backup where you will store the learned weights, last learned weights, right? And here in our thing, we are not downloading these weights because this weight file is also available. We are ignoring this. And then you are making this available for Unix environment so that it is easy to run. So what you're doing is you are installing this DOS to Unix package, and then you are converting them to Unix format. So all these files are converted to Unix, and then you start training, right? You are using train dataset and you are starting training with the available weights. And once the training has happened, weights will modify. Those are actually stored in the backup location. So once the weights have been modified and stored, you are actually going for what you say, making the needed bounding boxes available in the model. So for that, you are using mean average precision. So after that, you are going for bounding boxes prediction on the new image. So you are passing the test image here and you are predicting the bounding box. So whether bounding box has been obtained successfully or not on the new image. So you are displaying that result here. So you are using this displaying. After that, you are also what you say implementing the same detection on the images, right? Extending the same concept to images, sorry, videos, so that in the video also the objects have been detected and bounding box have been obtained, applied. So these are the things that we have seen in this hands-on session, right? If you want me to give the break for 5 minutes, I will give you break for 5 minutes. Or else if I want me to continue, I will continue. It is up to the participants. Can you please let me know?
Hello.
Yes, please.
Yeah, good afternoon, sir. This is
Good afternoon, sir.
Harjeet.
Sir.
So I have one question.
Yes.
Like, suppose if we run the same model.
Yes.
For different classes.
Yes.
Or different data set, then what will be the process?
You should actually modify the what you say names file. You should modify the configuration file, right?
Okay.
You should also modify the data file that you have seen altered earlier, right? So here in this file, we have altered three things, right? Configuration file, data file, and as well as the names file. So these values will change, sir. Here max batches will change, right? And the 80%, 90% max batches will change. And also the number of classes will change. Filters, the number of filters that you need to use will change. because all these things are actually dependent on the number of classes that you use in that are present in the images, right?
Okay.
And
But
then,
sir, so in that case,
yes,
shall we use the same configuration file?
that's what, sir. You should not use the same configuration. You should modify the values for these parameters. Parameters will be the same, and you should
Okay.
modify the values.
Okay.
In the
Okay.
yes, in the names files also you should provide the set of names which are available in the image in terms of objects, and data file these things, right?
Okay. But we should maintain the image sizes, that is 416 into 416.
That's up to you, sir. That is also up to you. Please try to understand. It should be in the multiples of 32.
Okay, multiple of 32.
Yes.
Okay. Okay, sir. Thank you.
Fine, sir. Fine. So as participants are very eager enough to continue, I will straight away move to the next topic, that is sliding window based object detection, which is the traditional way of detecting the objects from the image, right? So let me share that presentation with you.
Sir, can this, hello, sir?
Sir, please, sir, please.
Sir, can this architecture can be used for medical image analysis also? Is it?
Yes, sir. It is possible to use for medical image data set also.
So major changes as you specified, those values we need to change, or path selection we need to change?
No, sir. The values are to be changed in the configuration file and in the objects. How many objects you would like to classify first and then use for detection? Those names are to be specified, and only those two things you should modify in a major way. And these things are also are already there in the file. You should be careful enough that the number of classes values to be modified in that what is a data file.
So do we need to have a huge data set to train this?
Yes, sir. This actually, for the sake of hands-on, I have shown you only a less number of images for training and testing. In real time, the number of images will actually go up to 10,000.
Oh, okay.
So that's why GPU is the most important factor for the sake of computer vision tasks.
Oh, okay. Thank you, sir.
Yes, sir. Thank you, sir.
Excuse me, sir?
Yes, sir. Yes, sir. Please.
So what you said about the data set size, I mean for training?
Data set size, it is in our hands-on, it is, we are only dealing with 22 images, and for
Okay.
testing we are using 5 images only.
Okay, we no need to provide the more data.
You can scale it to 10,000 images, as I said now.
Okay.
You should keep in mind that your machine is configured in a better way.
Right, sir, right.
Fine, sir. So
Sir,
can
when
I?
we are drawing, yeah,
Yes,
sir, one
yes,
more
yes.
doubt. Sir, when
Yes,
we are
madam,
drawing
yes.
that bounding box, so
Yes.
we have to draw for all the images if you're uploading 10,000.
Here, yes, madam. Here you should use the logic. There is a repository for automation of this thing to bound the box to have the bounding boxes to the objects in the image. I will also share that repository to you, which automates this process. Your only task is to input these images folder to that particular logic, where that image, that logic, what it will do is it will take the image and it will apply the what you say bounding box.
So pre-processing we need to do that bounding box we need to draw in advance.
Yes, in advance you should do that
Using tools.
Yes, ma'am.
Please
Or
forward.
else that is the thing, that is manually it will happen, it takes time. So if you want to get the images with bounding boxes directly, I will also share the site after this session with all the participants. In the proper channel, through proper channel, you can use that site and you can actually download the images with the bounding boxes directly.
Oh, okay, sir.
Yes, ma'am. Thank you. Can I continue now? Participants, may I continue? Fine.
Yes, sir, please.
Yes, thank you. So this is the actual topic that we should talk first for the sake of object detection. Then we should actually go to this YOLO, because this is the traditional and the first object detection technique that is actually there since 1990s. Right? This is 1997 model. Please try to understand. From 1997, it is there. After that, advances have come till YOLO was invented or developed in 2015. Okay, so this is sliding window based object detection. So if you see, it's a very straightforward technique. So what is sliding window? First of all, so a sliding window is a fixed rectangular region with the corresponding fixed width and height. So now if you observe, you immediately will have a doubt. The doubt is, in YOLO, you are saying, did we ever talked about the fixed width and height for the sake of convolution in CNN, in darknet, let us say? No, we haven't talked, because the topic, the YOLO has the flexibility to not to have the bounding box or the, let us say, sliding window of fixed size, right? When it is not required to have fixed size. So that is the advantage with YOLO. But when it comes to the sliding window and other approaches, your window size is actually fixed with the height and width. It is also a rectangular region, right? It cannot be a rectangular region also in normal cases that you see in YOLO, right? So once the sliding window slides across the image, what happens is that slided in what part of the image is taken by the classifier, and the classifier, what it does is it determines whether that window has object or not, right? Window has object or not. So this was the pretty straightforward technique. So as you see in this slide, so you see, I quickly raise a question here, or I would like to ask the participants to raise the question that comes in your mind when you see this image. If you have the question in your mind, please let me know within 1 minute. What could be the question here?
It's a sliding window movement is random, or it should follow some fixed pattern.
Yes, it is sequential from left to right. You are seeing, madam. The sliding window is sequential. It is moving from left to right. Now, what could be the question here?
It is not covering total area, sir.
It is not covering total area, as per one of the participants says. Yes, in the sense, what do you mean by total area?
So total image is not covered fully, according to my perception.
Okay. Yes, sir. Your answer is right. And the thing is here, the region of interest is should be defined beforehand as we are doing classification. And the next thing is the size of this sliding window. The size of this sliding window is a tedious task. The finalizing the size of the sliding window is a tedious thing. It happens iteratively, and based on the require based on the object to be recognized or detected at hand. Accordingly, the size of the sliding window is finalized. So you will have a doubt. This image is of this much width and height, but the sliding window is the 3/4 of the region of the image. So is it correct to have that much sliding window? Yes, it is true for this image. It is true for this image because it covers facial features to the maximum extent in order to detect the face, right? So now moving on. So this is the sliding window detection algorithm. So these are the only 5 steps you see. So the first step is this algorithm chooses a specific size as a grid cell, right? It is, let us say it started with 2 by 2, but here as you see in the previous slide is not 2 by 2, right? Then what happens is once a grid cell is chosen, the image is what you say taken from that grid and it is convoluted. So convolution is not a new process. It is not a new operation, convolution operation, which is there earlier also. So I think we know what is meant by convolution. So if you have any doubt, you can ask me after this presentation. So once we do the convolution, what happens is the convolution works with feature kernel. So our feature detector, it takes that feature detector and it applies on the grid, and it will create the what you say modified value for that pixel that is present in the grid cell. So and then it is placed in the destination image. And this process of convolution happens and throughout the entire image with stride of 2. Stride of 2 means taking the 2 pixels and doing the convolution in the image. And this happens with the 2 pixels at a time. And once the entire what you say the slides entire grids have been convoluted by stride 2, then finally it is understood that entire image is actually considered for the sake of what you say sliding and detecting, and you can repeat the same procedure with different grid sizes. So as you see, this is the window size. If you observe, uh, we have iteratively tried with different sizes of the sliding window, and we finalized with one size of the sliding window, right? So this is a highly computational task, because every time you are trying out for different sizes of the sliding window, and you are uh, fixing with the window size, right? So this is the example as you see here. The sliding window is moving from left to right, what is it based on the grid size, and it is finally at this particular dog, right? The bounding, sorry, the sliding window is in this particular dog, right? And if you see, if you do inference, this sliding window size is actually dependent on this particular dog size in that image, right? Now, so the thing is, if you see, if I take small sliding window, what happens is it more number of features are to be what you say used.
Excuse me, sir.
Features are to be convoluted. Yes, please.
Sir, I am having a question here.
Yes.
Whether the sliding window and the filter, both are the
Yes.
same thing?
What
3 by
in
3
the
filter.
sense the size? In the sense the size?
In convolution neural network, we are
Yes.
having the kernel or the filter that is might be 3 by 3, 5 by 5, or 7
Yes.
by 7, and
Yes.
this is the same thing we are talking about.
Yes, madam. That is what I am saying here. You are using a different size convolution operator. You can use different size convolution operator. to do the
Right.
conversion process.
Correct.
Okay. And we are using the traditional max pooling technique here in order to find out the maximum value in the convoluted region of that particular grid, and we are carrying out towards the fully connected layer for what to say, for the sake of classification and detection, right? So now here this particular slide will tell you whether to choose small windows or larger windows, right? So that's why iteratively choosing the window size is required for this sliding window based detection method, right? So if you see this, this is the implementation of this particular sliding window method through CNN, right? So now if you see on the image on the image that is applied, so what happened? The bounding box, the is understood, let us say for the sake of our understanding, this is a bounding box, right? And that particular region is actually detected as having the object, with the because of sliding window, right? So now the interesting question arises here is how we represent that region, the grid cell image, the image in the grid cell as in the form of a particular mathematical notation, in the form of mathematical notation that we can see clearly in our what you say YOLO. I will quickly show you those two things, how mathematically we will represent, and we will stop there, right? So this is the accuracy versus speed trade-off across the object detection algorithms, the various object detection algorithms you are seeing here. Faster RCNN, fast RCNN, right? Single shot detection algorithm, and YOLO. So if you see, YOLO stands apparently in terms of speed when compared with the remaining object detection algorithms, and in terms of accuracy, it is in the lines of the other object detection algorithms. Now, the disadvantages with this sliding window is, as we see, it is time consuming because you are iteratively checking for the size of the sliding window, and it is computationally expensive because you are using deep learning models, or let us say you are using high classifiers for the sake of object detection. You can also go with SVM, as you see in the slide. You see here. You can also go with SVM, but with SVM it is okay, fine, because before CNN, before deep learning models are used, SVM is the most popular classifier that is used in conjunction with image processing or computer vision, right? So yes, after that CNN has come into picture, but with CNN you should also have good configuration machine to do this, right? So now, and also the most important thing is bounding boxes might not be accurate. That is because you are restricting yourself to fixed size of width and height. So thereby what happens is bounding boxes, predicted bounding boxes might not be accurate. So quickly, what is any doubts, please?
Excuse me, sir.
Yes.
I have one question related to faster RCNN and YOLO architecture.
Yes, please.
The question is like, although the YOLO architecture is faster than the faster RCNN, but the purpose of both the architecture or both the model is same or different?
The final purpose is the same, to identify or detect the objects from the image. But the faster RCNN, what it does is, instead of working with the individual feature maps, it works with what is called as regions. You see this region proposal. You see, this is a region proposal that it takes. You see, region
Okay.
proposal network. Understood?
Yes, sir. Yes. Thank you, sir.
In a fast RCNN, in RCNN, you will only work with individual proposals, but whereas in faster RCNN, you will group them
Okay.
into your convolution part, and then you do convolution.
Okay. Okay, sir. Thank you, sir.
So these are the comparisons that we can actually have across these three object detection models or algorithms. Right? As you see, the prediction timing is fast with faster RCNN, but still it is beyond 0.2 seconds, or that means it is very less when it comes to what you say, YOLO. Right? We are using version 4 of YOLO model.
Yes, sir. Yes.
Right. So now quickly we will go to the mathematical way of understanding this. I think this slide is visible. Cat and the dogs, right? Fine. Now quickly I will go to that mathematical way of working on this. See this one, as you observe, this particular image is pre-processed to convert that image into a vector. So this vector contains seven pieces of information. The first value in that vector is the probability of the object which has to be identified, right? So that's what I will simply what you say. See here in this slide. First one is probability of that particular object present in that image, PC. Now, if you target image is present in that object is present in that image, then PC value will be 1 or else it is 0. And next is the center of the bounding box, bx comma by. Center coordinates of the bounding box, bx comma by. And the next is bh comma bw, which are actually nothing but the height and width of that particular bounding box. Right, height and width of the particular bounding box. So how many values we have covered? 5 values we have covered. And the next values are the set of values which represent the classes of that particular objects present in that image. So if you are working with 80 classes, then 80 classes are to be represented. If 80 objects are present in that image, let us say if 80 are there, then all are 1. If only 1 is there, that particular value will be 1, remaining all will be zeros. Okay? These boxes are nothing but the what you say, the grids that you have actually created. Now what you are doing is you are representing that in the form of a vector like this. You see here, representing in the form of a vector, and you are multiplying these classes with the probability of that particular class, right? So let us say you want to go, let us say the model is to be only identify one class, then you will only use that particular class probability, and you will multiply with all the remaining class values, so which are present in that vector. So you will finally get with the set of scores in which you are finding the maximum value, which will allow you to identify that is a particular object, which is nothing but classification, and then you will trace back and get back the corresponding, what you say, the bounding box coordinates to predict the bounding box for that particular path. Okay. So this is actually the YOLO does. So many bounding boxes it will draw. You need this this is to be filtered, right? This will actually get filtered based on the box confidence. So that's why you are associating the IOU with the probability of that object. Then what is this IOU is? Intersection over union. So it is nothing but MAP that we have seen, right? Same as MAP. It is measure of overlap between actual value and the predicted value. So you see here, this is the overlap. This is the overlap region. of the bounding box, ground truth or bounding box present from the image training data and the estimated bounding box given by the model. And this particular overlap should be more. It is very clear. If the overlap is more, then the distance between the ground truth bounding box and the estimated bounding box is very less. So you see, more IOU, very good prediction of bounding box. That is the important thing. It is intersection over union. Simple formula. Numerator is the intersection of the bounding boxes. Denominator is the union of the bounding boxes. Right? So when numerator value is high, it means prediction is good. Bounding box prediction is good. That's what I would like to convey here in this presentation of YOLO. You see, this is the thing that is actually happening. So you see from the yes, we know that computers will see the image in this fashion only, and if that is the case, that computers can do this. Yes, it is possible. All these tasks can be carried out by computer, which we have seen now in the hands-on session. Yes, with this we come to the end of the today's session. So if you have any doubts, now the session is open for the doubts for the next 5 to 7 minutes, so that we can wrap the session. Any doubts, please? Fine. If there are no doubts, you can. I will give you my mail ID so that you can mail your doubts to this mail ID. I will happy to answer you. So thank you, Anupriya Madam, for giving me this opportunity to deliver the hands-on session on YOLO and the sliding window based object detection methods in computer vision, which are actually useful in today's real world problems. Thank you very much, madam.
Excuse me, sir.
Yes, please, madam.
So
Please.
I have a doubt on CNN, sir.
Yes, madam.
Sir, usually we divide the data set into training and testing data set, right, sir? So in that training data set alone, we will annotate, right, sir?
What allocation, madam?
No, sir. Annotation, sir. Labeling.
Annotation, yes, madam. On training data set only we do annotation.
Okay, sir. So when sometimes we go for validation also, no, sir. So
yes.
Validation data set we will be taking from the training data set. Correct, sir?
Yes, madam. We actually divide the entire data set into two parts. That is both training and testing. So validation, let us say here on the upper level, both are same. So when you do annotate the entire data set and then you will divide. For that reason, because of that only, it is possible to estimate or compare the predictions with the ground truth.
Okay, sir. So the validation data set also must be annotated only.
Yes.
Okay, sir. Okay.
Fine.
Thank you. Thank you, sir.
Right.
Faculty members, if you have any doubts, please you can post it here. Or if there are no more doubts, then I will proceed with the other discussions. Okay. Okay. So I understand there are no more doubts. So I'm closing the session and I'll go to the other discussions. See, some faculty members are telling that we haven't received the mails. Telling that if you are giving different your organization mails, sometimes it is bouncing back. and like you are using different registered mails are different, and you are logging in through the different mails. So that also is becoming an issue. So now I'll share the
attendance sheet, okay, because we are maintaining
attendance we are for every day. Okay, so till yesterday this is the percentage list. Okay, so this is what we could get it from the, we have filtered it from the WebEx, and we have these percentages in each session. Okay, so based on this mail ID only, we are actually finalizing the attendance. And say tomorrow is the final day of the FDP. After the last session, we will be having one assessment. Why is it echoing, sir? Is it echoing?
No, it's actually closed.
Okay. So once it is, so whoever has
not attended so far the assessment, those faculty members can attend. This is just to support the faculty members because they are attending the sessions with all the duties. I understand that. So that will be the assessment, final assessment, which will be taken for the absentees, whoever were absent so far can take up that assessment if you want that assessment to be uploaded and graded. Okay. So that is the option where you have to take it for all the assessments put together. You will be having some 50 questions. Fine. And apart from this, I think there are no more questions of the present session. And once the attendance is in such a way that I have to post all the attendance in a day itself. So tomorrow, once I complete the session, we will post the attendance and you can see it from the Atal site itself. Okay. If you have any other concerns, yeah, some of you are asking about the video. Yes, definitely. So we are planning to post it in the YouTube, but we may have to do some small editings, like removing the breaks, and we have paused, and so after doing that editing process, we will upload it in the YouTube as well as we will upload it in a drive, and I will give you an access. Okay. So if there are any other concerns, please do post it in the chat window.
Ma'am.
Yes, please.
Ma'am, for the attendance, ma'am, can I please have a look at the mail ID that you have recorded, or you can please spell it out.
Yeah. The mail ID for each, that's no problem. Because see, based on what is your registered mail ID?
Actually, my registered mail ID at Atal is gayatri.com.
Sorry, I'm not able to hear.
Ma'am, actually,
so much disturbance.
Yeah, so much disturbance. Ma'am, gayatridevik@yahoo.com. But I've been logging in through my official ID, gayatri@drngpit. Because we never thought of it, so that's why.
Okay, Ms. Gayatri, what you do
Yes,
is
ma'am.
you better post me in a separate. You have my WhatsApp number, right? The same
Yes,
number.
ma'am.
Yes, post your consent. I will okay. Like whatever
ma'am,
is
I'll
your
do it.
concern, whether you want. I think today I sent. I think I don't know whether this is. I have sent the day 1, day 2, day 3 also I have sent. If anyone has not received also, please send it to me. I will send it again.
Okay, ma'am.
This is for all of you. If any particular day, if you haven't received, please post me, okay, in the chat window. I will consider those email IDs and I will send it again to them.
Okay, ma'am. Thank you, ma'am.
Excuse me,
Ma'am, one
ma'am.
more. Excuse me, ma'am.
And if you have concerns, please post it in the there is a private chat in my WhatsApp. Do not post it in the chat window, okay? Because it is only if it is individual related, and if you have any specific concern, please post it in the WhatsApp, okay? Here we will try to give only the try to address only the common problems. See, session 6, okay, session 6, I understand that, there is some file corruption. I have requested once I receive, I will upload it for you.
Ma'am?
See, you have written only like, yes, please.
Ma'am, along with the materials, will you please post today's code also, ma'am, the Google Colab code, whatever sir taught today?
That I have already sent, no, Justina.
Okay.
You didn't receive it?
Today's code, ma'am?
Yeah.
Okay.
Today's code, like whatever sir has shared for the session, I have sent it before the session started itself. And some of them, they posted that they didn't receive. For them also, I have posted it again.
Okay, ma'am. Can I send you in WhatsApp, ma'am, my mail ID? Can you post? Because on and off the connection was interrupted because of the cyclone.
Okay, no problem.
Okay, ma'am.
Window, please do not post. Yes, Justina, it's fine. I'll send it to you. No worries.
Okay, ma'am.
Please
Okay. Thank
send
you,
your
ma'am.
mail ID. I'll send
Sure,
it to you.
ma'am.
No problem.
I'll WhatsApp you, ma'am. Thank you, ma'am.
Sure, no problem. And here, coming to the coding process, as if you are not speaking, can you please mute? Shaukat Ahmed, sir, do you want to tell something?
Yes, ma'am. Actually, I have one request, ma'am, and on 9th, I missed that assessment, ma'am. So I couldn't able to fill up that. Actually, the time was over, and in spite of that, I have requested you through your personal WhatsApp.
That's what.
So
Yeah, I understand, sir. So that is
yes,
what
ma'am.
whoever has
Actually,
not attended.
in the as you have already communicated that there will be a combined fund consisting of 50 questions and all the sessions I have completed all the assignments, but I missed on that particular day only. So what can I do for that, ma'am?
Okay, that's what. Shaukat sir, what we are planning
Yes,
for tomorrow is, we will.
yes,
I do not want all of you to take all the assessments. Not required. Okay.
okay,
We will
okay,
give you the option of taking
that particular one.
on day 2 or day 3 or day 4 or day
Okay,
you
ma'am.
missed
Okay,
that
fine.
alone.
Yeah, fine, ma'am. Okay,
You
ma'am.
don't
Thanks a
need to
lot, ma'am.
take all. Understand? Whoever has
Okay,
missed,
ma'am. Fine,
for
fine.
them I will
Okay,
slot the time. Okay, I will slice the time
okay,
and
okay,
I will give. So whoever has not taken
okay,
alone can take. Okay, sir?
okay,
You
ma'am.
understood?
Thank you. Okay,
At
ma'am.
what time, ma'am?
Yeah, thank you, ma'am.
Yes.
At what time it will start?
So tomorrow we have session up to 3 o'clock. Is it not? 1 minute. I hope you are. Am I audible? Am I
Yes,
audible?
ma'am.
Yes,
You are
ma'am.
audible.
See, actually, tomorrow our session will end by 3 p.m. Okay? So, from 3 o'clock to 4 o'clock, we have 1 hour time. So, during that time, give the, I will take today, I will circulate one Google form today in the WhatsApp window. In that, you can tell me who else have not taken. Understand? So based on that, I will open the link for those faculty members. You can take up testing. Fine. That is one aspect. Then there will be an overall feedback. tomorrow we will be conducting one overall feedback. That also we will try to complete it between 3 to 4. Okay, so no worries. We can complete it by whoever has not finished your assessment. So don't need to worry. If there is any other concerns, you can let me know. Otherwise, we can conclude the session.
Hello.
Yeah, today there will be assessment. Today there will be assessment again from evening 7 o'clock to 8 o'clock.
Madam, am I audible?
Today from yes, sir. Now I can hear you. Please tell me, sir.
Yes. Thank you, madam. Madam, on the day 1 assessment, I had actually applied. I had actually performed on the day 2 morning. Am I required to do it again? Day 1 assessment I had actually performed on the day 2 morning. Am I required to do it again?
Day 1 you did it on day 2, huh?
Yeah, day 2 morning, very early morning.
Like, sir, if it has been counted or not, because only with that time slice we have given the forms. After that, it will not take the responses. Let me check, and I will let you know. Okay.
Okay.
There is
Thank you so
nothing
much.
wrong in taking it again. If you really need it, you can take.
Okay.
What is there? You wanted to repeat it. Not a problem.
Okay, fine. Yeah, fine. Thank you.
Anything else, participants? Attendance will not be shared to you because like there are whoever present you want, because based on the WebEx link, the attendance has been shared, and I didn't find any problem with any faculty members, because some of them they are trying to join with the other IDs, and some of them are any concerns, you can let me know. We don't want people to misuse the attendance sheet, so we will not give. If you want personally, you can check. See, it will not be shared. If you want to check, like, madam, I have attended these many sessions, means you post in personal video, I will cross check and let you know. That's not a problem. See, for one particular region, I cannot, reschedule. So the test will be as usual, but I have given another option also, no, Ms. Archana, like tomorrow. So tomorrow you can take if you are not able to attend it today. Yes, tomorrow 3 to 4 is the for all. It is only for the absentees. For all that is related to tomorrow's session, for all it will be only in the night, 7 o'clock to 8 o'clock. The absentees alone can take up the test between 3 to 4. From 4 to 4:30, I expect participate for the feedback. I would like to hear from you. Giving the feedback form is fine, but I would like to hear your experiences also, so that it will be helpful for us to conduct again in a very good manner, or to improve the FDP. Fine?
Ma'am, I have one question. Can I?
Yeah. I think there are other concerns. Thank you very much. Yes, please.
Ma'am, yeah. I was saying that
Yes,
generally the final test is conducted on the last day. So tomorrow's will be that test which for which the eligibility criteria will be 60%.
No, madam, we are not taking that into consideration. Here, see, that final test, because see, they will be conducting, it differs from FDP to FDP. In some FDPs, they are conducting only one test at the end. But in our case, we are conducting test on every day, 7 to 8.
Ma'am, but because it was told before.
So you will be able to attend that test also. Yeah, because we are taking only those participant list and we are sharing it.
Yeah,
And we are taking
my
only those into account.
my concern is because daily it was conducted and sometimes it was difficult. So we have given the examinations. I have attempted all the examinations, and because it was told the assessment will not be considered for the marks, okay, the regular assessment. So I was asking tomorrow's will be the last for which I should score some criteria fixed marks, then only I will get certificate, or if I attempt all, then I will also get the certificate. What will
No,
be?
if you have attended all the assessments.
Okay.
You have attended all the assessments. Okay.
Yes.
And doesn't matter even if you have not scored well also, but
Okay.
we will give you the score for grading. But for certificate, there is no necessity. Only thing is you have to attend all the days and all the assessments.
Yes, ma'am. That we have done. Thank you so much.
Hello, ma'am. Anupriya, ma'am.
You understood?
Hello, ma'am.
I'm repeating it again. It is something like, see,
Hello.
the assessment was given. Hold for a minute, sir. The assessment is given for you to test yourself, right? So all the you must the assessment and for the certificate there are two criteria. One is grade and one is criteria. Okay. Now the grade will be based on what you have attended all the days. It has nothing to do with the certificate. But when it comes to the certificate, you must have attended all the sessions and all the assessments. Then you will be given the certificate. Yes, any other concerns?
Yes, ma'am. Anupriya, ma'am. Myself, Abhishek Mathur. And ma'am,
Yes,
I was unable to submit my assessment for day 2 actually. And except day 2 assessment, I have submitted all the assessment. So it is required me to appear in the tomorrow's assessment from 3 to 4.
Yes.
Okay.
Whichever day, see, we have 5 days, right? In
Yes,
the
ma'am.
5 days, some of you must have attended 3 days. Some of you must have attended 4 days, like that, right?
Okay.
So whoever has not attended that day assessment, for example, you have not attended day 2 assessment means
Yes.
attend only that.
Okay, ma'am. Okay. Thank you, sir. Thank you.
Okay. So
Anupriya, ma'am.
tomorrow day test will be, for example, 1 minute, madam. Day
Yes, ma'am.
5 test will be usual conduct, no change in that. Whoever has missed, okay, whoever
Okay, ma'am.
has missed a particular day, those people can take in that window of 3 to 4. Got it? So today we will circulate a Google form where you can very clearly tell the your mail ID, your name, and you have not attended which day. So accordingly, we will also share the link to you so that you can take the test tomorrow between 3 to 4. Yes. Yes, Sridevi, madam.
Yes,
Sridevi
ma'am.
only, right?
Yes,
madam.
ma'am. Thank you. Ma'am, day 1, the test link have been posted at the
Tell me, ma'am.
almost
What is your question?
somewhat of late night at 9:35. 9:35, ma'am. So I had attempted the quiz, the next day. Can I able to know that whether it have been accepted or not? That
I will check that, madam. I will check that
Okay.
and I will let you know, because here we have divided the tasks. So let me find out from the person and I will
Okay.
know who else have attempted in each day. Okay. So that
And
I will
ma'am,
put it by today evening.
yes.
I will try to put that.
Okay, and if possible, share any link in view mode, madam, so that we can check the data.
For which one, madam?
Like, these assessments we had attempted or not, or the mail IDs. If you had posted in a view mode, so that we can
Okay,
check
I'll
and
put
cross
it.
check whether that's correct or not.
Yes, ma'am.
Cross-checking is fine, ma'am. Yes, I agree.
Yes.
But at the same time, we should also be on from our side also, like, we are registering in one, we are attending in another, we are looking for something, means It is very difficult from our side also
Of course, ma'am. That's what I am asking to share in a view mode only, so that we
Anyhow,
can
you said,
cross-check.
like I will try
And if
to.
any issues are there, then we can text you personally, not all the members.
Yeah, better.
Yes.
See, actually here I see for in my case, I don't want to get into each and individual chat and keep looking because I'm getting many messages.
Yes. I too agree, ma'am. Because we too also face
So
these type of
I didn't want
issues.
to go for the private chat of everybody.
Yeah.
Yeah, these type of issues. That's what I'm telling, like if you have any concerns, I see the respect of each one of you is very important to me.
Yes.
So if you have any individual concerns, please do post it in my personal, what is that, WhatsApp chat. I will take care.
Okay, ma'am. Thank you so much.
Okay, then thank you very much, all of you. If there are no more concerns, then I will close. No separate final test based on whatever you have attempted on day to day only will be considered. We will consolidate and today's test will be in the evening as usual from 7 to 8. Thank you. I hope we can conclude the session. Thank you all.